Hello there, and welcome to Just About Earth, a quiet corner where curiosity settles in gently and science takes its time. This is a place for slow thoughts, soft questions, and long journeys through the natural world, especially the ones that don't rush toward answers. Tonight, we're stepping into a version of Earth that feels both familiar and strange, a world shaped by cold, patience, and immense stretches of time. A world where ice was not just a season, but a defining presence. Before we go any further, take a moment to notice where you are right now. Maybe you're listening from a warm room, wrapped in a blanket, or perhaps the air around you is already carrying a hint of winter. What part of the world are you in tonight, and what time is it there in your own little pocket of the planet? It's interesting to think about, especially as we begin talking about a time when the idea of clocks, calendars, or even years meant nothing at all. If you find this gentle exploration calming, or if learning about Earth's deep past helps your thoughts slow down at the end of the day, you're always welcome to like the video or subscribe. It helps this quiet space reach others who might also be looking for something steady and unhurried. And now, with nothing you need to do but listen, let's begin easing our way into a colder world. When people hear the words Ice Age, it's easy to picture a frozen planet locked in snow from pole to pole, a kind of endless winter where nothing moves and life struggles to exist. That image isn't entirely wrong, but it's far from complete. The Ice Age, or more accurately the Ice Ages, were not a single moment, or even a single era. They were long, complex periods marked by cycles of cold and relative warmth, advances and retreats, survival and adaptation. Life didn't stop during these times. It adjusted, slowly and persistently. The most recent ice age, known as the Pleistocene, began around 2.6 million years ago and ended roughly 11,700 years ago. That span of time is so vast that it's difficult to hold in the mind. Entire species appeared, thrived, and vanished within it. Landscapes we recognize today were repeatedly transformed, sometimes beyond recognition. Ice sheets expanded across continents, then pulled back again, leaving behind valleys, lakes, and soils that still shape where we live now. Yet even during the coldest stretches, Earth was not uniformly frozen. Enormous ice sheets covered much of North America, northern Europe, and parts of Asia, sometimes reaching several kilometers thick. These glaciers moved slowly, almost imperceptibly, grinding rock beneath them and reshaping the land over thousands of years. But beyond the ice, vast regions remained ice-free. These areas, often cold and dry, supported grasslands, tundra, forests, and an astonishing variety of life. To understand what life was like during the Ice Age, it helps to step away from the idea of a single frozen moment and instead imagine a world in motion, even if that motion was slow. Climate shifted gradually. Temperatures rose and fell. Ice advanced and retreated. Sea levels dropped and rose again. And through all of this, living things responded in ways that were practical rather than dramatic. One of the most striking differences between the Ice Age world and our own is how much lower the sea level was. So much water was locked up in glaciers that the ocean shrank, exposing vast stretches of land that are underwater today. Continental shelves became dry ground. Entire land bridges appeared, connecting places that are now separated by seas. One of the most famous of these was Beringia, the land bridge that linked Siberia and Alaska. It wasn't a narrow strip of land, but a broad region that supported grasses, shrubs, animals, and eventually humans. This connection allowed species to move between continents, shaping ecosystems on both sides. Without the Ice Age and its lowered seas, the biological map of the world would look very different. Despite the cold, the Ice Age was not a silent or empty time. It was an age of animals, many of them large, well adapted to harsh conditions and deeply tied to the landscapes they inhabited. Mammoths roamed open plains, their thick fur and layers of fat protecting them from the cold. Woolly rhinoceroses grazed alongside them, as did steppe bison, horses and giant deer. Predators like saber-toothed cats, cave lions and dire wolves followed these herds, moving across enormous territories. These animals did not wander aimlessly through snowstorms. Many lived in environments that, while cold, were also productive. The mammoth steppe, for example, was a vast biome stretching across much of the northern hemisphere. It was dominated by grasses and low plants, sustained by dry, cold conditions rather than heavy snowfall. This landscape supported immense numbers of grazing animals, which in turn shaped the vegetation through their feeding and movement. Plants too were active participants in this world. Tundra plants grew low to the ground, conserving heat and resisting wind. Coniferous forests shifted southward during colder periods, then crept north again as temperatures rose. Even in the depths of glacial times, life found ways to persist, often in forms that look modest at first glance but proved remarkably resilient. Humans were part of this story as well. Our species evolved during the Ice Age, and much of what it means to be human was shaped under these conditions. Early humans learned to live with cold, scarcity, and unpredictability. They followed animals across open landscapes, used fire not just for warmth but for cooking and protection, and crafted tools that made survival possible in environments that could change over a lifetime. It's important to remember that Ice Age humans were not primitive in the way the word is often used. They were skilled observers of their surroundings. They understood animal behaviour, seasonal changes, and the properties of materials like stone, bone, and wood. They adapted their clothing, shelters, and movement patterns to suit the land and climate they lived in. Some groups built temporary structures from hides and mammoth bones. Others sheltered in caves or used natural features for protection. Life during the Ice Age required constant attention to the environment. There were no fixed settlements in the way we think of them today for most of this time. Instead, people moved as conditions demanded, following food sources, avoiding danger, and responding to shifts in weather and landscape. This mobility was not a sign of instability, but of flexibility, a way of staying in balance with a world that was always changing. The cold itself was not always the greatest challenge. In many regions, dryness posed a serious problem. Glacial climates often meant less precipitation, leading to dustier environments and limited water availability. Plants and animals adapted accordingly, and humans learned where water could be found even during harsh seasons. It's also worth noting that the Ice Age was not one long, uninterrupted freeze. There were warmer intervals known as interglacial periods, when ice retreated and climates became more like what we experience today. We are currently living in one such interglacial period, the Holocene. During these warmer times, forests expanded, sea levels rose, and human populations grew and spread. Then, slowly, the cycle would begin again. This rhythmic pattern of cooling and warming was driven by subtle changes in Earth's orbit and tilt, known as Milankovitch cycles. These shifts altered how sunlight was distributed across the planet over tens of thousands of years. On their own, they were small changes, but over long periods they were enough to tip the balance between ice growth and melting. For the living beings of the Ice Age, these changes were not sudden catastrophes, but slow transitions. Species migrated, adapted or declined over many generations. Extinction did occur, especially toward the end of the last Ice Age, when rapid warming and human pressures combined. But for much of the Ice Age, life was not on the brink. It was persistent, resourceful, and deeply connected to the rhythms of the planet. As we ease further into this colder version of Earth, it becomes clear that the Ice Age was not simply a backdrop of ice and snow. It was a dynamic world filled with movement, interaction, and long-term change. Landscapes shifted under the weight of glaciers. Animals carved paths across continents. Humans learned, adjusted, and endured. And as we continue, it's worth keeping in mind that much of the world we recognize today, from rolling hills to deep lakes and fertile soils, owes its shape to these ancient stretches of cold. The Ice Age is not a distant, irrelevant past. It is written into the ground beneath our feet, quietly influencing the present. There was no sudden switch that flipped, no single winter that announced itself as the beginning. Instead, the Earth eased into colder rhythms so gradually that no living thing at the time would have recognized it as a turning point. The planet did not freeze all at once, it slowed. Temperatures dipped by fractions of degrees over thousands of years. Snow lingered longer each year in higher latitudes. Summers grew slightly shorter, winters slightly more persistent. And in that slow accumulation of small changes, ice found its opportunity. To picture this shift, it helps to stop thinking in terms of seasons as we know them. During this long cooling phase, the Earth's climate system behaved less like a repeating calendar and more like a deep, slow inhale and exhale. Heat was still moving around the planet, oceans still circulated, winds still blew, but the balance was changing. Less sunlight reached certain regions during key parts of the year, and that imbalance, though subtle, had consequences that compounded over time. The primary driver behind this gradual cooling lay far beyond daily weather. It was written into the mechanics of the planet's movement through space. Earth does not orbit the Sun in a perfect circle, nor does it keep its axis at a fixed angle. Over tens of thousands of years, its orbit stretches and relaxes, its tilt shifts slightly, and its wobble changes direction. These cycles, known as Milankovitch cycles, alter how solar energy is distributed across the planet, particularly at high latitudes. What mattered most was not how cold winters became, but how cool summers remained. In regions near the poles, snow that fell during winter needed warm summers to melt away. When summers grew just cool enough that some of that snow survived year after year, it began to pile up. A little extra snow reflected more sunlight back into space, keeping the surface cooler. Cooler surfaces allowed more snow to persist. This feedback loop, simple but powerful, set the stage for ice to expand. At first, these accumulations were modest. Snowfields lingered on mountain ranges and northern plains. Over time, the weight of this snow compressed it into ice. As layers built up, gravity took over. Ice began to flow outward. Not quickly, not dramatically, but steadily. What we call glaciers were not static, frozen slabs. They were slow-moving rivers of ice, inching forward year after year, reshaping the land beneath them. As these ice sheets expanded, they altered the climate further. Massive glaciers, kilometers thick, pressed down on the Earth's crust, depressing it under their weight. At the same time, their bright surfaces reflected sunlight, amplifying cooling across large regions. Cold air spilling off the ice sheets influenced weather patterns far beyond their edges. Winds shifted, precipitation patterns changed. Regions that were once forested became open grasslands or tundra. Oceans responded as well. As water became locked up in ice on land, sea levels dropped. Coastlines moved outward, sometimes by hundreds of kilometers. Shallow seas drained away, exposing land that had not seen daylight in millions of years. This newly exposed terrain altered ocean currents, which in turn affected how heat was transported around the globe. The climate system, already sensitive, adjusted again. Despite all of this, the cooling did not proceed in a straight line. There were pauses and partial reversals. Warmer intervals interrupted the advance of ice, allowing glaciers to retreat before pushing forward again. These fluctuations created a patchwork of environments. Some areas were locked beneath ice, others remained cold but ice-free, and still others experienced climates not unlike modern northern regions, with seasonal variation rather than perpetual freeze. For plants and animals, this shifting world required flexibility. Species that thrived in warmer forests gradually migrated southward, or adapted to cooler conditions. Cold-tolerant plants expanded their ranges, colonizing new ground left behind by retreating ice, or exposed by falling seas. Grassland spread in many regions, especially where colder, drier conditions limited tree growth. These open landscapes would later become central to Ice Age ecosystems. The spread of ice was not uniform across the planet. The southern hemisphere experienced glaciation as well, but its geography shaped the outcome differently. Antarctica became increasingly ice-covered, developing the massive ice sheet that still dominates it today. In the northern hemisphere, large land masses at high latitudes allowed ice to grow across continents. North America and Eurasia bore the brunt of glacial expansion, while regions closer to the equator experienced cooling without full glaciation. This uneven distribution of ice created stark contrasts. In some places, towering walls of ice marked the horizon. In others, cold winds swept across open plains dotted with hardy vegetation. The world was not silent or lifeless, but it was quieter in some ways. Forest canopies thinned, animal populations shifted, migration routes lengthened. Survival depended less on abundance and more on efficiency. As ice advanced, it sculpted the land in ways that would persist long after it melted. Moving ice scraped soil and rock from some regions and deposited it in others. Valleys were carved deeper, hills were flattened, rocks were ground into fine sediments that would later form fertile soils. Lakes were gouged out where ice scoured the ground, filling with meltwater during warmer periods. These changes were not visible within a single lifetime. They unfolded over spans of time that dwarfed generations. A species might experience only the early stages of cooling, adapting slightly, shifting its range, never knowing the full extent of the transformation underway. Yet evolution works precisely on these timescales. Small advantages mattered. Thicker fur, seasonal behaviours, altered diets, and flexible movement patterns became increasingly valuable traits. For early human ancestors, this slow cooling shaped the environments in which they evolved. Open landscapes favoured endurance walking and long-distance travel. Variable resources rewarded problem-solving and cooperation. Fire became increasingly important, not only for warmth, but for cooking and protection. Clothing, shelter, and tool use gained urgency as cold periods lengthened. It is important to resist the idea that the Ice Age was a single dramatic event that life had to endure all at once. Instead, it was a long negotiation between the planet and the organisms living on it. Ice advanced because conditions allowed it to. Life responded because it had time to adjust. When conditions shifted again, ice retreated, and life followed new paths. During colder phases, atmospheric carbon dioxide levels dropped, reinforcing cooling. This reduction was partly driven by changes in ocean circulation and increased storage of carbon in the deep ocean. As temperatures fell, the oceans absorbed more CO2, which further reduced the greenhouse effect. Once again, a feedback loop took hold, tightening the grip of cold. Yet the system was never locked permanently. Over time, orbital shifts increased summer sunlight at high latitudes. Ice began to melt. As it retreated, darker land and water surfaces absorbed more heat, accelerating warming. Carbon dioxide levels rose again, released from oceans and soils. The planet began to exhale, slowly reversing what it had built up over tens of thousands of years. This cycle of advance and retreat repeated many times during the Ice Age. Each cycle reshaped ecosystems slightly differently. Species adapted, migrated, or disappeared. New combinations of plants and animals emerged. Human populations expanded and contracted, following resources and retreating from advancing ice. From a modern perspective, it is tempting to imagine ice as an invading force, something hostile and destructive. But in the context of Earth's long history, ice was simply another agent of change. It redistributed water, reshaped land, and influenced the evolution of life. Without these glacial periods, many of the landscapes we depend on today would not exist in their current form. As ice sheets crept outward, they did not erase life. They reorganized it. Life retreated from some areas and concentrated in others. Refugia, pockets of relatively stable climate, became sanctuaries for plants and animals. When conditions improved, these refuges served as sources for recolonization. This pattern of contraction and expansion left genetic signatures that scientists can still trace today. Even the concept of north and south took on new meaning. Regions that are temperate today were once harsh and inhospitable, while areas farther south became centres of biological activity. The familiar map of ecosystems shifted repeatedly, reminding us that what feels stable now is only a temporary arrangement. As the Earth continued this long cooling, ice became a defining feature of the planet's surface. Not everywhere, not all the time, but enough to leave an enduring mark. The presence of ice influenced winds, oceans, and life itself. It slowed some processes and accelerated others. It demanded patience from the planet and resilience from its inhabitants. At first glance, glaciers might seem like little more than frozen obstacles, immense and unmoving, but that impression hides their true nature. A glacier is not a block of ice frozen in place. It is a slow, persistent force, moving forward under its own weight, reshaping everything it touches. During the Ice Age, these vast rivers of ice became some of the most powerful architects the planet has ever known, working patiently over thousands of years, indifferent to scale, grinding mountains and smoothing plains with equal persistence. As ice sheets expanded across continents, they behaved less like weather and more like geology. Their movement was measured not in days or seasons, but in lifetimes. A glacier might advance only a few centimetres or metres per year, yet given enough time, that was more than enough. Rock cracked under pressure. Soil was scraped away. Entire landscapes were remodelled without sound or spectacle. There were no crashes, no sudden collapses, just the constant pressure of ice pressing forward, grain by grain. Beneath a glacier, the ground experienced forces unlike anything in today's temperate environments. The immense weight of ice compressed the land, sometimes by hundreds of meters. Bedrock fractured under stress. Stones frozen into the base of the ice acted like sandpaper, grinding and polishing whatever lay beneath. Over time, sharp peaks were worn down into rounded hills. Valleys once carved by rivers were widened and deepened into broad U-shaped corridors that still define many mountainous regions today. Where glaciers advanced, they stripped landscapes nearly bare. Soil, vegetation, and loose rock were pushed aside or carried along within the ice. These materials did not disappear. They travelled with the glacier, sometimes for hundreds of kilometres, before being released elsewhere. When ice eventually slowed or melted, it dropped this load in thick, uneven deposits known as till. These deposits formed rolling hills, ridges and plains that had never existed before. Some of the most recognisable features left behind by glaciers are moraines, long ridges of rock and debris that mark the edges of former ice sheets. These ridges trace the slow breathing of the ice, showing where it paused, advanced, or retreated. In some regions, multiple moraines sit like contour lines on the land, each one a record of a different moment in the Ice Age's long progression. Water played a crucial role alongside ice. As glaciers moved, pressure and friction caused melting at their bases, even in extremely cold conditions. Meltwater flowed beneath the ice in hidden channels, carving tunnels through rock and sediment. These subglacial rivers could be surprisingly powerful, capable of moving large boulders and cutting deep grooves into the ground. When the ice eventually disappeared, some of these channels remained as valleys or dry riverbeds, puzzling features until their glacial origins were understood. At the edges of ice sheets, meltwater pooled into enormous lakes. These glacial lakes were often temporary, held back by walls of ice or sediment. When those natural dams failed, water surged across the land in catastrophic floods. These outburst floods, though rare, reshaped regions in a matter of days or weeks, scouring surfaces clean and leaving behind rippled landscapes that still bear the marks of sudden release. Wind, too, became a powerful force in this colder world. With large areas stripped of vegetation by ice or cold, dry conditions, loose sediments were easily picked up and carried across vast distances. Fine particles of ground rock, produced by glacial grinding, became airborne, forming dust clouds that settled far from their source. Over time, these windblown sediments accumulated into thick layers known as loess, creating fertile soils that would later support agriculture long after the Ice Age ended. These dusty winds altered ecosystems in subtle but lasting ways. In some regions, they enriched soils with minerals, while in others, they buried existing vegetation. The constant movement of dust affected plant growth, animal behaviour, and even atmospheric processes. Ice did not act alone. It worked in concert with air and water, each element reinforcing the other's effects. Silence in this context was not an absence of life, but an absence of rapid change. The Ice Age landscape was quiet in the sense that nothing happened quickly. Mountains did not rise overnight. Rivers did not suddenly change course without reason. The dominant forces moved slowly, predictably, and relentlessly. For any individual organism, the world might seem stable. For the planet as a whole, it was in the midst of one of its most active periods of transformation. As glaciers advanced and retreated, they repeatedly rerouted rivers. Some waterways were blocked entirely, forced to carve new paths around ice barriers. Others were dammed, creating lakes that lasted centuries or millennia. When the ice finally withdrew, rivers often did not return to their old courses. The land they once followed had been altered too drastically. This reshuffling of drainage systems reshaped ecosystems and influenced where plants, animals, and later humans could thrive. Coastlines were also transformed. With sea levels lowered by the vast amount of water locked in ice, shorelines extended far beyond their present boundaries. Rivers cut deeper channels into continental shelves, creating valleys that would later flood when sea levels rose again. These drowned valleys became estuaries, bays, and fjords, many of which are still among the most biologically productive regions on Earth. In mountainous areas, glaciers carved dramatic features that remain striking today. Sharp ridges, called arêtes, formed where glaciers eroded adjacent valleys. Bowl-shaped depressions known as cirques marked the birthplaces of mountain glaciers. Jagged peaks rose where ice ate away at surrounding rock from multiple directions. These landscapes, often admired for their rugged beauty, are direct results of long-term glacial work. Flat regions were not spared. Ice sheets spread across plains, smoothing them into broad expanses. In some areas, the retreating ice left behind thousands of shallow depressions that filled with water, forming chains of lakes. This is why regions like northern North America and Scandinavia are dotted with countless lakes, a quiet legacy of melting ice. As glaciers pressed down on the Earth's crust, they caused it to sink. When the ice melted, the land did not immediately rebound. Instead, it slowly began to rise, a process known as isostatic rebound. In some places, this uplift continues today, thousands of years after the ice has vanished. Shorelines shift, ancient beaches now sit high above modern sea level, and the land quietly adjusts to the absence of weight it carried for so long. This slow rebound affected ecosystems as well. Areas once submerged became dry land again, altering habitats and migration routes. Coastal regions change shape gradually, sometimes over centuries, giving plants and animals time to adapt. The planet did not snap back. It eased into its new form just as it had eased into the Ice Age itself. The silence of glacial landscapes also influenced how life moved through them. Large open spaces shaped by ice and wind favoured animals capable of long-distance travel. Migration routes stretched across continents. Herds followed seasonal patterns dictated not just by temperature, but by the availability of plants growing in soils freshly laid down by retreating ice. Predators adapted their strategies to these wide, exposed terrains. For early humans, these reshaped landscapes presented both challenges and opportunities. Open plains allowed visibility over great distances, making it easier to spot animals and other groups. River valleys created natural travel corridors. Glacial deposits provided raw materials for tools, from flint and quartz to other workable stones carried far from their original sources by ice. The land itself became a resource, shaped long before humans arrived but ready to be used. It is easy to think of glaciers as destructive, and in many ways they were. They erased forests, displaced ecosystems, and made large regions temporarily uninhabitable. Yet they also created new environments. Fresh soils supported new plant communities. Meltwater fed rivers and lakes. The retreat of ice opened vast areas for colonization by life, including humans. Throughout the Ice Age, the planet existed in a state of balance between these opposing forces. Ice advanced, then withdrew. Wind stripped and deposited sediments. Water carved and filled. Silence allowed processes to unfold without interruption. This balance was not static, but dynamic, always adjusting to small changes in climate and solar input. Over tens of thousands of years, the combined effects of glaciers, wind, and water left the Earth profoundly altered. Mountains were reshaped, plains were leveled, coastlines were redrawn. Even regions untouched by ice felt its influence through shifting climates and redistributed sediments. No part of the planet existed entirely outside this system. As the Ice Age progressed, these reshaped landscapes became the stage upon which life continued its long story. Animals adapted to new terrains, plants colonized freshly exposed ground. Humans learned to read the land, to follow its contours, to understand where water flowed and where shelter could be found. And yet, all of this change happened without drama. No single moment marked the transformation. The land did not announce itself. It simply changed, quietly and persistently, under the steady pressure of ice and the constant movement of air and water. As the cold deepened and ice accumulated on land, one of the most far-reaching changes unfolded far from the glaciers themselves, along the edges of continents and across the shallow margins of the seas. Water that once filled oceans was slowly drawn upward and outward, locked into ice sheets that spread across the land. This process did not happen suddenly, but its effects were unmistakable over time. Sea levels fell, not by a few meters, but by tens, and eventually more than 100 meters during the coldest stretches. The oceans pulled back, exposing land that had been hidden beneath water for thousands or even millions of years. Where waves once moved, dry ground emerged. Continental shelves became wide plains, shallow seas drained away, and coastlines crept outward, sometimes by hundreds of kilometers. The familiar shapes of continents changed. Islands merged with mainlands. Narrow straits closed. Entire regions that are now separated by water became continuous landscapes, open to wind, animals, and human footsteps. These exposed lands were not empty corridors. They developed their own environments shaped by cold, wind, and seasonal change. Some were grassy plains. Others were dry tundra or sparse woodlands. Rivers crossed them, fed by meltwater from distant ice sheets, or by precipitation falling on land that had never before existed above sea level. These temporary worlds became bridges, not just between places, but between ecosystems, species, and populations that had long been isolated from one another. Among the most well-known of these connections was Beringia, the broad landmass that linked northeastern Asia with northwestern North America. Rather than a narrow strip, it was a vast region stretching hundreds of kilometers from north to south. During much of the Ice Age, it remained largely ice-free, sheltered by dry conditions that limited snowfall. Grasses and low plants grew there, supporting large grazing animals. Predators followed. Eventually humans did too. Beringia was not a single moment in time, but a recurring feature during periods of low sea level. It appeared, disappeared, and appeared again as ice advanced and retreated. Each time it emerged, it allowed movement between continents that would otherwise have been impossible. Animals crossed back and forth, shaping the future ecosystems of both Eurasia and the Americas. Species that originated on one continent spread to the other, sometimes thriving, sometimes fading away. Similar connections existed elsewhere. In Southeast Asia, lowered seas exposed the Sunda Shelf, linking mainland Asia with islands that are now part of Indonesia. Elephants, rhinoceroses, tigers, and early humans moved across these lands, spreading through environments that today are separated by deep water. To the west, the British Isles were connected to mainland Europe by a broad plain often referred to as Doggerland, a low-lying landscape of rivers, marshes and grasslands. Doggerland was not a barren crossing. It was a living region, supporting animals, plants and human groups for thousands of years. People hunted, gathered and travelled across it, unaware that the ground beneath them would eventually be reclaimed by the sea. As sea levels rose near the end of the Ice Age, Doggerland flooded slowly, retreating year by year until only memories remained, preserved now beneath the waters of the North Sea. These land connections reshaped the patterns of life on Earth. Migration no longer depended on narrow coastal routes or risky sea crossings. Instead, animals followed familiar terrestrial paths, guided by vegetation, water sources, and seasonal cycles. Herds expanded their ranges. Genetic exchange increased. Isolated populations met, mixed, or competed. The biological boundaries defined by oceans softened, replaced temporarily by open land. For humans, these lowered seas and connected continents transformed what was possible. Movement no longer required boats or advanced technology. Journeys could be made on foot, over generations rather than expeditions. Groups expanded slowly, following game, tracking seasons, responding to local conditions. There was no single migration wave sweeping across continents. Instead, there were countless small movements, pauses, retreats and advances, shaped by climate, resources and chance. Travel during the Ice Age was not easy, but it was familiar. Humans evolved as walkers. Long distances did not require planning in the modern sense. They unfolded across lifetimes. Children were born in one place and grew old in another. Stories, tools and traditions travelled with people, adapting to new environments along the way. Over time, entire continents were settled not through conquest, but through gradual presence. The lowered seas also altered coastlines in ways that changed daily life. Coastal resources shifted outward. Shellfish beds, kelp forests, and marine hunting grounds moved farther from what are now modern shores. People living near the coast adapted by following these changes, establishing camps near new shorelines and abandoning older ones as the sea retreated. When the climate later warmed and sea levels rose again, these patterns reversed, sometimes forcing rapid adjustments. Rivers responded to falling sea levels as well. With oceans lower, rivers cut deeper channels as they flowed toward distant coastlines. Valleys extended across continental shelves, carving paths that would later flood and become estuaries. These river systems served as natural highways across the exposed land, guiding both animals and humans. Water, even in a cold world, remained central to movement and survival. The climate of these exposed lands was often harsh. Cold winds swept across open plains with little shelter. Vegetation was sparse in some regions, richer in others. Seasonal extremes could be pronounced, with short summers and long demanding winters. Yet life adapted. Animals developed migratory strategies, moving with the seasons to access food. Humans learned to read these patterns, timing their movements to coincide with animal behaviour and plant availability. It is tempting to imagine these journeys as purposeful marches toward unknown destinations, but that idea belongs more to modern storytelling than to Ice Age reality. Movement was rarely about reaching a specific place. It was about staying within a network of familiar landscapes, expanding gradually as conditions allowed. A valley here, a river there, a plain that offered good grazing. Over generations, these small expansions added up to continental-scale change. Lowered seas also influence climate by altering ocean circulation. Narrow straits that today funnel water between basins were closed, redirecting currents and changing how heat moved around the globe. These shifts fed back into regional climates, reinforcing cold conditions in some areas and creating pockets of relative warmth in others. The world became more varied, not less, despite the overarching presence of ice. In some cases, lowered sea levels exposed hazards as well as opportunities. Mudflats, unstable sediments, and rapidly changing river courses made certain regions difficult to cross. Seasonal flooding could cut off routes that were passable at other times of year. The Ice Age world demanded attention and flexibility. There were no permanent roads, only patterns learned through experience. As humans spread across these connected lands, they encountered environments that differed subtly from place to place. Tools were adjusted, clothing styles changed, diets shifted depending on available plants and animals. Cultural traditions diverged while retaining shared roots. Over time, these differences accumulated, contributing to the diversity of human cultures that would later flourish in more stable climates. The temporary nature of these land bridges is one of their most important features. They existed long enough to allow movement, but not forever. As the climate began to warm near the end of the last ice age, glaciers melted, releasing vast amounts of water back into the oceans. Sea levels rose, slowly at first, then more rapidly during periods of intense melting. The land connections that had shaped life for tens of thousands of years began to disappear. For animals, rising seas meant retreat or adaptation. Some populations became isolated once more, trapped on islands or peninsulas. Others followed shifting coastlines inward. Extinctions occurred in some cases, survival in others. For humans, the loss of land bridges marked a profound transition. Routes that had been used for generations vanished beneath the waves. Communities became separated. New technologies, including boats, gained importance. The memory of these drowned lands did not disappear immediately. For many generations, people would have witnessed the sea advancing, swallowing familiar ground, forcing camps to relocate again and again. Stories likely formed around these changes, passed down through oral traditions. Even today, myths of lost lands and rising waters echo across cultures, faint reflections of real events experienced by Ice Age peoples. From a geological perspective, the reflooding of continental shelves transformed Earth once more. River valleys became estuaries rich in life. Coastal plains turned into shallow seas. Marine ecosystems expanded into spaces that had briefly belonged to terrestrial ones. The planet adjusted, as it always does, to the redistribution of water and heat. Looking back, it becomes clear that the Ice Age was not just a time of cold, but a time of connection. Lowered seas linked worlds that are now separate. They allowed life to move, mix, and adapt on a global scale. Without these periods of connection, the distribution of species, including our own, would look very different today. These journeys on foot, made without maps or borders, reshaped the biological and cultural fabric of Earth. They unfolded slowly, guided by climate, land, and necessity rather than intention. Each step was small, but together they formed paths that crossed continents and ages. As the seas fell and rose, the world revealed and concealed its pathways, reminding us that geography is not fixed. Land can appear where water once ruled, and water can return to claim what seemed solid. Long before anyone tried to name it, the Ice Age followed a rhythm. Not a neat beat you could tap your foot to, and not a pattern that repeated on a human scale, but a slow, deliberate cycle that unfolded over tens of thousands of years. Cold gathered, ice expanded. Then gradually warmth returned, ice loosened its grip, and the planet shifted again. This was not a single event, but a repeating process, one that required a kind of patience far beyond everyday experience. To understand life during the Ice Age, it helps to understand this rhythm, because nothing about that world was static. Glaciers advanced and retreated many times. Forests moved south, then north. Sea levels fell, then rose. Animals and humans lived not in a permanently frozen world, but in one that was always in the process of becoming something slightly different. The drivers of this rhythm were subtle. There was no dramatic change in the sun's output, no sudden cooling of space. Instead, the key lay in the geometry of Earth's orbit and orientation. Over long periods, the planet's path around the sun stretched and relaxed. Its axial tilt shifted by a few degrees, and its orientation wobbled slowly like a spinning top. These changes altered how sunlight was distributed across the planet throughout the year. The most important factor was summer sunlight in the high latitudes. When summers were slightly cooler, snow that fell during winter did not fully melt. That leftover snow accumulated, compacted, and eventually became ice. Once ice began to grow, it reflected more sunlight back into space, reinforcing the cooling. When summers grew warmer again, ice melted more efficiently, and the process reversed. This meant that ice ages were not defined by endless winter, but by summers that failed to erase the past. A single cold summer did not matter much. Thousands of them, each just a little cooler than before, mattered a great deal. These cycles unfolded over predictable timescales. One orbital pattern repeated roughly every 100,000 years. Another operated on a 41,000-year cycle. A third ran closer to 23,000 years. Together they combined to create complex patterns of cooling and warming. The result was a climate system that never stood still, even when change was slow. During colder phases, known as glacial periods, ice sheets expanded across large portions of the northern hemisphere. During warmer intervals, called interglacials, ice retreated, sometimes dramatically. The world we live in now exists within one of these warmer pauses. From the perspective of deep time, it is a temporary state, not the norm. What makes this rhythm remarkable is not just its regularity, but the way life adapted to it. Plants and animals did not experience climate as a smooth curve. They experienced it locally, through changes in seasons, precipitation, and available resources. A gradual cooling might mean shorter growing seasons, altered migration routes, or shifts in predator-prey relationships. Over generations, these pressures shaped behaviour and biology. Trees, for example, did not move as individuals but as populations. As temperatures dropped, forests slowly retreated southward or downslope, replaced by grasslands or tundra. When warmth returned, they advanced again, seed by seed. This movement was slow enough that it often took thousands of years for forests to reclaim regions once abandoned. During that time, entirely different ecosystems flourished. Animals responded more quickly. Large herbivores followed vegetation zones, migrating as needed to find food. Predators followed them. Some species developed wide tolerance ranges, allowing them to survive across changing conditions. Others became specialized for cold or warmth and were forced to retreat or disappear when conditions shifted beyond their limits. Humans were part of this adaptive process. Early human populations did not face a single ice age challenge, but a series of them. A group might experience a cooling trend over several generations, followed by relative warming, followed by cooling again. Knowledge accumulated slowly. Techniques that worked in one phase had to be modified in another. Fire management, clothing, shelter design, and food storage all became increasingly important as climate variability intensified. The rhythm of the Ice Age rewarded flexibility. Groups that could adjust their habits, move when necessary, and diversify their food sources were more likely to persist through long-term change. It is tempting to imagine Ice Age climate change as dramatic, but most of it was quiet. A river froze slightly longer each year. A familiar plant bloomed later in the season. Snow lingered into early summer where it once melted away. These changes did not announce themselves as crises. They accumulated, gradually reshaping environments until adaptation was unavoidable. This long patience of climate also meant that extinction was rarely sudden. Most species declined over extended periods as their preferred habitats shrank or fragmented. Some managed to survive in refuges, isolated pockets where local conditions remained suitable. These refuges became reservoirs of genetic diversity, allowing species to expand again when conditions improved. The presence of refuges was crucial. Southern Europe, parts of East Asia, and areas of the southern United States provided relatively stable climates during colder phases. These regions supported forests and animal populations, while northern areas lay under ice or tundra. When glaciers retreated, life flowed outward from these refuges, recolonizing newly available land. This process repeated many times. Each cycle left its mark, subtly altering which species dominated, how ecosystems were structured, and where populations were located. The Ice Age was not a single test of survival, but a series of long negotiations between climate and life. Atmospheric composition played a role in these rhythms as well. During colder periods, carbon dioxide levels were lower. Some of this carbon was absorbed by colder oceans, which can hold more dissolved gas. Some was locked away in expanded ice sheets and changes in vegetation. Lower greenhouse gas concentrations reinforced cooling, creating another feedback loop. When the climate warmed, the oceans released carbon dioxide back into the atmosphere, amplifying the warming. Vegetation patterns shifted again, altering carbon storage on land. The climate system responded as an interconnected whole, with ice, oceans, atmosphere, and life influencing one another continuously. What stands out is how slow all of this was. From a human perspective, climate change today feels rapid and disruptive. During the Ice Age, similar processes unfolded over thousands of years. This slow pace allowed for adaptation, migration, and evolution. It also meant that no generation ever experienced the full arc of change. People lived within a slice of the cycle, responding to local conditions without seeing the long pattern behind them. Even so, long-term memory mattered. Knowledge passed down through generations could encode responses to recurring challenges: when to move, where water persisted during dry phases, which animals returned reliably after harsh winters. Culture became a tool for surviving climate rhythm, preserving information beyond individual lifetimes. The rhythm of the Ice Age also introduced a sense of uncertainty into ecosystems. No state was permanent. A forest might thrive for thousands of years and then vanish. A grassland might spread across continents and later fragment. This instability favoured generalists over specialists, resilience over optimization. In this context, patience was not passive, it was active endurance. Plants endured cold by growing slowly, conserving resources. Animals endured by migrating, hibernating, or altering diets. Humans endured by cooperating, sharing knowledge, and adjusting social structures to match environmental demands. There is an important distinction between resilience and resistance. During the Ice Age, life did not resist change by holding conditions constant. It persisted by flowing with change, adjusting incrementally as the climate shifted. This dynamic stability allowed ecosystems to survive repeated disturbances without collapsing entirely. As glacial cycles continued, they left behind layered records in ice cores, sediments, and fossil distributions. These records show how predictable the rhythm was, and how tightly linked climate and life became. Each layer tells a story of advance or retreat, cooling or warming, abundance or scarcity. Eventually the rhythm shifted again. Orbital conditions favoured warmer summers. Ice sheets began to melt more rapidly. Sea levels rose. The planet entered the current interglacial period. From a geological standpoint, this was just another phase. From a human standpoint, it changed everything. Agriculture became possible. Permanent settlements formed. Human populations grew rapidly. Yet even now, the long patience of climate has not disappeared. The underlying rhythms continue, though they are now joined by new forces introduced by human activity. Understanding the Ice Age rhythm reminds us that climate is not a background feature. It is an active process, constantly shaping the possibilities of life. During the Ice Age, this process unfolded slowly enough to allow adaptation, but steadily enough to reshape the planet again and again. Across the open landscapes of the Ice Age, where trees were sparse and the horizon stretched wide, some of the largest land animals to ever exist moved steadily through the cold. These were not rare or mythical creatures in their time. They were common, familiar presences, shaping the land as much as it shaped them. The frozen plains were home to giants, and life there revolved around their movements, their needs, and the space they occupied. Among the most iconic were the mammoths. Covered in long, coarse hair and insulated by thick layers of fat, mammoths were built for cold in a way few animals ever have been. Their curved tusks, sometimes reaching several meters in length, were not just decorations. They were tools, used to sweep aside snow to reach buried grasses, to strip bark from trees, to dig for water, and to defend against predators or rivals. Every part of a mammoth's body reflected adaptation to a demanding environment. Mammoths were not a single uniform species. Several types existed, each suited to slightly different conditions. The woolly mammoth is the one most people imagine, roaming the cold steppe and tundra of the northern hemisphere. Other mammoths lived in warmer regions earlier in the Ice Age, with less hair and different proportions. Over time, as climates cooled, the woolly forms became dominant in higher latitudes. Mastodons, often confused with mammoths, were close relatives but lived somewhat different lives. Their teeth reveal much about their habits. While mammoths had flat, ridged molars ideal for grazing on grasses, mastodons had cusp teeth better suited for browsing on leaves, twigs and shrubs. As a result, mastodons tended to inhabit forested or mixed environments rather than open plains. Where mammoths thrived on wide grasslands, mastodons moved through woodlands shaped by the edges of ice. These giants were not solitary wanderers. Mammoths, in particular, lived in social groups much like modern elephants. Herds were typically led by older females, with males leaving the group as they matured. This social structure offered protection, shared knowledge of landscapes, and cooperative care for young. In a world where survival depended on knowing where food and water could be found during harsh seasons, collective memory mattered. The frozen plains themselves were not barren wastelands. The mammoth steppe, stretching from Western Europe across Asia and into North America, was a productive ecosystem dominated by grasses, sedges and low-growing plants. Cold temperatures and low precipitation favoured grasses over trees, creating vast grazing lands. These plains supported not only mammoths and mastodons, but also steppe bison, wild horses, musk oxen, and giant deer. The presence of these large herbivores shaped the ecosystem in profound ways. As they grazed, they prevented shrubs and trees from taking over, maintaining open landscapes. Their movement churned soil, dispersed seeds, and redistributed nutrients through dung. In winter, when they scraped snow away to reach vegetation, they exposed patches of ground that smaller animals could also use. The giants were ecosystem engineers, maintaining the very conditions that allowed them to thrive. Predators evolved alongside them. Saber-toothed cats, with their elongated canine teeth, specialized in bringing down large prey. Cave lions, larger than modern African lions, hunted across open plains. Dire wolves travelled in packs capable of challenging formidable animals. These predators did not eliminate the giants, but they influenced their behaviour, encouraging vigilance, group living, and migration. The relationship between giants and predators was part of a larger balance. Large herbivores reproduced slowly, investing heavily in a few offspring. Calves required years of care before reaching independence. This made populations vulnerable to rapid changes, whether from climate shifts, habitat loss, or increased predation pressure. Stability mattered. Long periods of relatively consistent conditions allowed these species to persist. Seasonality defined their lives. Summers were brief but productive, offering abundant forage that allowed animals to build fat reserves. Winters were long and demanding. Snow covered much of the ground, temperatures dropped far below freezing, and food became harder to access. Migration was one strategy. Many herds moved seasonally, following routes shaped by geography, vegetation, and experience passed down through generations. The sheer scale of these animals affected how they interacted with the cold. Their large bodies retained heat more efficiently than smaller animals. Thick fur trapped air close to the skin. Fat provided insulation and energy. Even their ears were adapted smaller and more compact than those of modern elephants, reducing heat loss. Evolution had fine-tuned them to their environment with remarkable precision. Despite these advantages, life on the frozen plains was not easy. Calves were especially vulnerable during harsh winters. Injuries could be fatal. Droughts or unusual weather patterns could disrupt food supplies. The Ice Age climate, though slow-moving, still produced variability that tested even the most well-adapted species. Humans entered this world not as immediate rulers, but as participants. Early human groups encountered mammoths and mastodons as part of the existing landscape. These animals represented both opportunity and danger. A successful hunt could provide meat, fat, bones, and hides sufficient to support a group for weeks or months. Failure could mean injury or death. Evidence from archaeological sites shows that humans hunted mammoths, though likely not as frequently or casually as popular images suggest. Bringing down such a large animal required cooperation, planning, and favourable conditions. Humans likely targeted young, old, or weakened individuals using terrain to their advantage. Natural features such as ravines, muddy ground, or icy slopes could turn the giant's size into a liability. Beyond food, mammoths were central to material culture. Bones and tusks were used to construct shelters, particularly in regions with limited wood. Hides provided insulation and clothing. Tools fashioned from ivory and bone served practical and symbolic purposes. These animals were woven into human survival strategies in ways that extended far beyond the hunt itself. Mastodons, living in more wooded environments, may have been encountered differently. Dense vegetation, limited visibility and movement. Hunts there would have relied more on ambush and intimate knowledge of forest terrain. The relationship between humans and these animals varied depending on region and culture, reflecting local conditions rather than a single pattern. The giants of the frozen plains were not static figures frozen in time. Over the course of the Ice Age, their ranges shifted repeatedly. As glaciers advanced, suitable habitats contracted. As ice retreated, grasslands expanded. Mammoths moved with these changes, sometimes spreading into new areas, sometimes retreating into refuges where conditions remained favourable. Toward the later stages of the Ice Age, pressures on these animals increased. Rapid warming altered vegetation patterns. Grasslands gave way to forests in many regions, reducing suitable habitat for grazing specialists like mammoths. At the same time, human populations grew and expanded into new territories, increasing hunting pressure. The combination proved difficult for many giant species to withstand. Extinctions did not occur all at once or everywhere. In some regions, mammoths disappeared earlier. In others, small populations survived surprisingly late. Isolated groups on islands persisted thousands of years after mainland populations vanished, protected temporarily by geography from both climate change and human hunting. Eventually, even these refuges were lost. The disappearance of these giants reshaped ecosystems once again. Grasslands changed without constant grazing. Nutrient cycles shifted. Predators lost key prey species and declined or adapted. Humans adjusted their diets and strategies, turning more towards smaller animals, fishing, and eventually plant cultivation. The Ice Age world moved into a new phase. Looking back, it is tempting to frame mammoths and mastodons as symbols of loss, representatives of a vanished age. Yet during their time, they were not relics or anomalies. They were successful, widespread, and deeply integrated into their environments. Their long tenure speaks to how well life can adapt to even the harshest conditions given time and stability. While the giants of the Ice Age often dominate our imagination, they were only one part of a far more intricate living world. Beneath their towering presence, around their migration routes, and sometimes within the shelter of their shadow, countless smaller animals lived out lives shaped by cold, scarcity, and constant adjustment. These creatures did not command attention through size or spectacle, yet their endurance tells an equally important story. In many ways, they were better suited to the Ice Age than the giants, because survival in a colder world often favoured flexibility over strength. Small and medium-sized animals experienced the Ice Age very differently from mammoths or mastodons. Their bodies cooled faster, they lost heat more easily, food shortages affected them sooner. At the same time, they reproduced more quickly, adapted faster, and could exploit niches that larger animals could not. Their success depended not on dominating the landscape, but on navigating its shifting constraints with efficiency. One of the most widespread and successful Ice Age animals was the reindeer, also known as caribou in North America. Reindeer thrived across vast northern regions, moving seasonally in enormous herds. Unlike mammoths, which relied heavily on grasses, reindeer had a more varied diet. They fed on grasses in summer, but in winter they turned to lichens, mosses, and low shrubs buried beneath snow. Their hooves were broad and sharp-edged, allowing them to dig through snow and ice with ease. Reindeer also possessed a unique adaptation that made life in low-light conditions easier. Their eyes changed colour seasonally, shifting from golden hues in summer to deep blue in winter. This adaptation improved their ability to see ultraviolet light reflected by snow, making predators and food easier to detect in the long, dim months. In a world where daylight could be scarce for much of the year, this small adjustment mattered enormously. Alongside reindeer lived musk oxen, stocky animals built low to the ground with dense underwool that trapped heat close to their bodies. Musk oxen were not fast, but they were resilient. When threatened by predators, they formed defensive circles, protecting calves at the centre. This behaviour reduced vulnerability and allowed them to persist in regions where fleeing across open terrain would have been dangerous or impossible. Smaller herbivores also flourished. Arctic hares, for example, developed compact bodies and thick fur that changed colour with the seasons. White in winter, brown or grey in summer, they blended into their surroundings, reducing the risk of predation. Their powerful hind legs allowed them to move quickly across snow, escaping danger despite their small size. Rodents played a surprisingly important role in Ice Age ecosystems. Lemmings, voles, and ground squirrels lived beneath the snow, where temperatures were more stable than above the surface. Snow acted as insulation, creating a subnivean layer where these animals could move, feed, and reproduce. Their burrowing activity aerated soil, influenced plant growth, and provided food for a wide range of predators. Population cycles among these small mammals were dramatic. Lemming populations, in particular, rose and fell in pronounced waves. During peak years, their numbers exploded, providing abundant food for foxes, owls, and other predators. When populations crashed, predators were forced to adapt, migrate, or decline themselves. These cycles rippled through the ecosystem, shaping relationships between species over time. Predators smaller than the Great Ice Age hunters were just as important to the balance of life. Arctic foxes, for instance, were masters of efficiency. Their thick fur, compact bodies, and keen senses allowed them to survive in some of the harshest conditions on Earth. They followed larger predators, scavenging leftovers, but also hunted rodents independently. Their ability to switch between food sources made them particularly resilient. Wolves, though larger than foxes, occupied an intermediate position between giants and small animals. Ice Age wolves were often larger than modern ones, adapted to hunting big prey like reindeer and bison, yet they also hunted smaller animals when necessary. Their social structure allowed them to cooperate, share food, and raise young even when conditions were difficult. Wolves could travel long distances, tracking herds across changing landscapes shaped by ice and wind. Bird life during the Ice Age was more dynamic than one might expect. Many species migrated seasonally, moving south during the harshest months and returning north in summer. Others adapted to year-round cold. Snowy owls, for example, hunted rodents across open tundra, using silent flight and sharp vision to locate prey beneath snow. Their plumage provided both insulation and camouflage. Waterfowl depended heavily on the presence of meltwater lakes and rivers. As glaciers advanced and retreated, these water sources shifted location, forcing birds to adjust migration routes continually. Some species thrived in these dynamic conditions, exploiting newly formed wetlands rich in nutrients released by glacial sediments. Insects, often overlooked in discussions of the Ice Age, were fundamental to ecosystem function. Cold-tolerant species persisted through winters in larval or dormant states, emerging briefly during short summers. Pollinators adapted to compressed growing seasons, timing their activity precisely to coincide with flowering plants. Without insects, plant reproduction would have faltered, affecting every level of the food web. Cold did not eliminate reptiles and amphibians entirely, but it restricted them to warmer refuges. In southern regions or during interglacial periods, these animals expanded their ranges. When conditions cooled again, they retreated. Their presence waxed and waned with the climate rhythm, illustrating how Ice Age ecosystems were not uniform, but mosaics of opportunity and constraint. Fish populations also responded to glacial conditions. Cold, oxygen-rich waters supported species adapted to low temperatures. Rivers fed by glacial melt fluctuated seasonally, sometimes dramatically. Fish had to cope with variable flow, sediment loads, and changing habitats. Those that could tolerate these shifts survived. Others vanished from affected regions. The success of smaller animals was closely tied to behavioural adaptation. Hibernation became a crucial strategy. Bears, though large, relied heavily on this approach, retreating into dens during winter to conserve energy. Smaller animals did the same, entering torpor or deep hibernation to survive periods when food was scarce and temperatures were extreme. Migration offered another solution. Birds, some mammals, and even insects used movement to escape the worst conditions. These migrations were not static routes, but flexible patterns adjusted over generations. Ice reshaped landscapes repeatedly, forcing animals to relearn pathways and timing. Those unable to adjust disappeared. Camouflage was another powerful tool. Seasonal colour changes reduced predation risk. Fur density shifted with temperature. Even behavioural camouflage, such as remaining still or active at specific times, improved survival odds. In a world dominated by open spaces and snow-covered ground, visibility was both an advantage and a danger. For humans living among these animals, smaller species were often more reliable food sources than giants. While mammoths provided immense rewards, they were risky and rare targets. Small and medium-sized animals could be hunted more frequently. Rabbits, birds, fish, and rodents supplemented diets and provided fur, sinew, and bone for tools and clothing. This reliance influenced human behaviour. Trapping, fishing, and small-game hunting techniques became increasingly sophisticated. Knowledge of animal habits, seasonal cycles, and habitats grew over generations. Humans learned when certain animals would be abundant, when they would vanish, and how to exploit brief windows of opportunity during short summers. The endurance of smaller animals also influenced vegetation patterns. Grazing pressure from herbivores shaped plant communities. Burrowing altered soil composition. Seed dispersal occurred through fur, droppings, and caching behaviour. These interactions maintained ecosystem function, even as climate shifted repeatedly. One of the reasons smaller animals endured where giants failed lies in reproduction. Shorter lifespans and higher reproductive rates allowed populations to recover quickly from losses. A harsh winter might wipe out many individuals, but survivors could repopulate rapidly when conditions improved. Giants, with long gestation periods and extended care for young, lacked this flexibility. This difference became critical toward the end of the Ice Age, when climate warmed rapidly and human pressures increased. Smaller animals adjusted by shifting ranges, altering diets, or increasing reproduction. Many giants could not respond quickly enough. Their disappearance left ecosystems increasingly dominated by smaller, more adaptable species. Even today, many animals thriving in cold regions trace their success back to adaptations honed during the Ice Age. Arctic foxes, reindeer, and lemmings are living examples of strategies refined over tens of thousands of years. Their presence reminds us that endurance does not always look dramatic. Often it looks like persistence through repetition, adjustment through habit, and survival through restraint. The Ice Age world was not defined solely by its most impressive inhabitants. It was sustained by countless small lives interacting quietly with their surroundings. These animals formed the connective tissue of ecosystems, linking plants to predators, soil to atmosphere, and seasons to survival. As the climate continued its slow rhythm, these smaller creatures adapted again and again, carrying life forward through cycles of advance and retreat. Their endurance set the stage for the environments humans would eventually inherit as ice loosened its grip. And while their stories are quieter than those of mammoths or saber-toothed cats, they are no less essential. Long before animals crossed frozen plains or humans learned to read the land beneath their feet, plants were already doing the slow work of survival. During the Ice Age, life did not persist only through movement and muscle. It persisted through roots, leaves, spores, and seeds. Quietly, steadily, and without spectacle, plants adapted to cold, dryness, shifting soils, and extreme seasonality. They formed the foundation of every Ice Age ecosystem, even when they were barely visible above the snow. To imagine Ice Age plant life correctly, it helps to let go of images of lush forests blanketed in ice. Much of the world during glacial periods was not buried under permanent snow. Instead, large regions existed as tundra, steppe, or sparse woodland. These landscapes were defined less by what grew tall and more by what grew low, close to the ground, protected from wind, cold, and grazing. The tundra became one of the most widespread biomes of the Ice Age. Stretching across high latitudes and elevated regions, tundra environments were shaped by cold temperatures, short growing seasons, and frozen ground beneath the surface. Permafrost, soil that remained frozen year-round, prevented deep root growth and limited drainage. As a result, plants had to survive with shallow roots and make the most of a brief window each year when the upper soil thawed. Despite these constraints, tundra was far from lifeless. Mosses, lichens, grasses, sedges, and small flowering plants formed dense, resilient mats. These plants grew slowly, but they grew reliably. Many hugged the ground, using the earth itself as insulation. Low stature reduced exposure to wind and helped trap warmth near the surface. In this way, the tundra became a living carpet, flexible yet persistent. Lichens played a particularly important role. Technically a partnership between fungi and algae, lichens were exceptionally well suited to Ice Age conditions. They required little soil, tolerated extreme cold, and could survive long periods of dormancy. When moisture and light became available, even briefly, they resumed growth. Reindeer and other herbivores relied heavily on lichens during winter, making these humble organisms critical to the survival of larger animals. Grasses and sedges dominated the mammoth steppe, one of the most productive Ice Age ecosystems. Unlike tundra, which existed in colder and often wetter regions, the steppe was cold and dry. Snowfall was limited, allowing grasses to remain accessible for grazing animals. These grasses grew quickly during short summers, producing large amounts of biomass in a compressed time frame. Their roots stabilized soil and prevented erosion, even as wind and ice shaped the land. What made grasses particularly successful was their growth strategy. Instead of growing from the tips, many grasses grow from the base. This meant that grazing did not kill them outright. Animals could feed repeatedly without destroying the plant, allowing grasslands to persist under heavy herbivore pressure. This mutual relationship between plants and grazers helped maintain open landscapes across vast regions. Shrubs also found ways to endure. Willow, birch and dwarf shrubs grew low and spread horizontally rather than vertically. Some propagated through underground runners, allowing them to expand slowly even when above-ground growth was limited. In protected areas, such as south-facing slopes or river valleys, shrubs formed dense patches that offered shelter and food for animals and humans alike. Trees did not disappear during the Ice Age, but their ranges shifted dramatically. Boreal forests retreated southward during colder phases, replaced by tundra and steppe. In warmer interglacial periods, trees advanced north again, reclaiming territory. This back-and-forth movement occurred repeatedly, reshaping ecosystems over thousands of years. Trees survived glacial periods by persisting in refuges. These were regions where local conditions remained mild enough to support forests, even as surrounding areas cooled. Southern Europe, parts of East Asia, and areas of North America served as such refuges. Within them, tree species maintained populations that later expanded when climates warmed. Without these refuges, many forest species would have vanished entirely. Seeds were another key to persistence. Many plants produce seeds capable of remaining dormant for extended periods. Some seeds could survive freezing, drying, and burial, waiting years for favourable conditions. When ice retreated or climates shifted, these seeds allowed plants to recolonize rapidly. Life did not need to start over, it resumed. Soil itself was constantly changing under Ice Age conditions. Glacial grinding produced fine mineral particles, which were carried by wind and deposited as loess over wide areas. These loess soils were rich in nutrients, though often low in organic matter at first. As plants colonized them, organic material accumulated, gradually building fertile ground. Much of the world's most productive agricultural land today rests on these Ice Age deposits. Plant growth influenced climate in return. Vegetation affected how much sunlight the surface absorbed or reflected. Darker plant-covered ground absorbed more heat than bare soil or ice, contributing to localized warming. Plants also played a role in the carbon cycle, absorbing carbon dioxide during photosynthesis and storing it in biomass and soils. As vegetation expanded or contracted, atmospheric carbon levels shifted, reinforcing broader climate trends. During colder phases, reduced vegetation meant less carbon stored on land, contributing to lower atmospheric carbon dioxide levels. During warmer periods, expanding forests and grasslands absorbed more carbon, altering the balance again. These feedbacks were slow but powerful, tying plant life directly into the rhythm of the Ice Age. Seasonality defined plant life more than temperature alone. Summers were short, intense bursts of activity. Plants flowered quickly, set seed rapidly, and stored energy for the long dormant period ahead. Growth that might take months in warmer climates had to occur in weeks. Timing mattered. A late frost or early snowfall could mean failure for an entire season. Many plants adapted by synchronizing growth with daylight rather than temperature. Long summer days at high latitudes provided extended periods of sunlight, allowing photosynthesis to continue even when temperatures were modest. This adaptation helped compensate for the brevity of the growing season and allowed tundra and steppe to support surprisingly high productivity during summer. For animals, these plant cycles dictated movement and behavior. Herbivores timed migrations to coincide with peak plant growth. Predators followed. Humans learned to anticipate these patterns as well, planning movements and resource use around the seasonal availability of plants and the animals that depended on them. Plants also provided direct resources for humans. Edible roots, berries, seeds, and leaves supplemented diets dominated by animal products. While plant foods were often seasonal and less calorie-dense, they offered essential nutrients and variety. Knowledge of where and when these plants could be found was passed down through generations, forming an important part of cultural memory. Beyond food, plants supplied materials. Fibres were used for cordage. Wood, when available, provided fuel and structural support. Resins, barks, and leaves had medicinal or practical uses. Even in cold environments, humans developed intimate relationships with plant life, relying on subtle cues to locate and use resources efficiently. Fire management interacted closely with vegetation. In some regions, humans used fire deliberately to shape landscapes, encouraging the growth of certain plants or attracting grazing animals to newly cleared areas. Even without human influence, natural fires occurred during dry periods, reshaping plant communities and creating mosaics of different growth stages. The quiet persistence of plants during the Ice Age is easy to overlook because it lacked drama. There were no migrations spanning continents, no towering forms casting long shadows. Yet without this persistence, none of the more visible life could have survived. Plants stabilized soils, fed animals, moderated climate, and stored the energy that fueled ecosystems. As ice advanced and retreated, plant communities reorganized again and again. Some species tracked climate shifts closely, moving their ranges. Others adapted in place. Some disappeared entirely. What remained was not a static landscape, but a living system constantly adjusting to slow change. Toward the end of the Ice Age, warming accelerated. Ice sheets melted rapidly. Sea levels rose. Forests advanced northward. Grasslands fragmented. New plant communities emerged, reshaping habitats once more. The tundra retreated in many regions, replaced by woodlands and mixed forests. For plants, as for animals, the world was changing again, yet the legacy of Ice Age vegetation remains. Modern tundra, boreal forests and grasslands carry genetic and ecological traces of those long cold periods. Soils formed under glacial conditions continue to support life. Plant strategies developed for endurance still shape how ecosystems function today. Long before cities, borders, or written memory, human lives unfolded beneath skies that felt endlessly wide and often unforgiving. During the Ice Age, early humans lived in a world defined not only by cold, but by openness. Vast plains stretched for days of travel. Tree cover was sparse in many regions. The horizon was rarely broken by anything taller than a distant hill or a slow-moving herd. Above it all, the sky dominated daily experience, changing light, colour, and weather in ways that shaped how people thought, moved, and survived. These early humans were not visitors to the Ice Age world. They were products of it. Our species, Homo sapiens, emerged and spread during this long period of climatic fluctuation, alongside other human relatives such as Neanderthals and Denisovans. The Ice Age did not merely challenge them, it shaped their bodies, their behaviours, and the social systems that allowed them to persist. Living beneath cold skies required constant attention to the environment. Temperatures could shift dramatically between seasons, and sometimes within days. A clear sky could mean brutal cold at night. Heavy cloud cover might bring snow, wind, or sudden thaw. Early humans learned to read these signs not through instruments, but through experience passed down across generations. Survival depended on anticipating change rather than reacting to it too late. Clothing became essential. Unlike animals adapted to cold with thick fur, humans relied on layered coverings made from animal hides and furs. Preparing these materials took time and skill. Skins had to be cleaned, scraped, softened, and sewn together using bone needles and sinew. Poorly made clothing could mean frostbite or death. Well-made garments allowed humans to inhabit regions that would otherwise be inaccessible. Shelter was equally important. Early humans did not rely on a single type of dwelling. In some regions, caves provided natural protection from wind and cold. Elsewhere, people built temporary structures using wooden frames, hides, and sometimes bones from large animals like mammoths. These shelters were not permanent homes but seasonal camps, assembled and dismantled as groups moved through their territories. Fire was central to life beneath Ice Age skies. It provided warmth, light, protection from predators, and a way to cook food, making it easier to digest and safer to eat. Maintaining fire required constant effort. Embers had to be protected during travel. Fuel had to be gathered, even in landscapes where wood was scarce. In treeless regions, people burned dried grasses, shrubs, or even animal dung. Cooking changed how humans interacted with their environment. Meat could be preserved by drying or smoking. Frozen carcasses could be thawed and consumed months after an animal was killed. Plants that were otherwise inedible became usable once cooked. Fire extended the usefulness of available resources, reducing waste and increasing resilience during lean periods. Movement defined Ice Age human life. These groups were mobile not because they lacked the ability to settle, but because their environment demanded it. Animals migrated, plants grew seasonally, water sources shifted. Humans followed predictable patterns rather than random wandering. Territories were known, remembered, and revisited. Movement was often cyclical, tied to seasons rather than exploration for its own sake. Despite this mobility, humans were not isolated individuals drifting through empty land. Social bonds were essential. Cooperation made large hunts possible. Sharing food reduced the risk of starvation. Knowledge about landscapes, animals, and weather was distributed across the group. Elders played a crucial role, carrying memory of past winters, dangerous places, and successful strategies. Children grew up immersed in this shared knowledge. Learning was constant and practical. How to identify tracks in snow, how to judge ice thickness on rivers, how to position a shelter to block prevailing winds. These skills were not abstract lessons. They were reinforced daily by necessity. Early humans beneath Ice Age skies also lived alongside other human species. Neanderthals, adapted to cold climates with stockier builds and robust physiques, occupied large parts of Europe and Western Asia. They hunted large animals, used fire, made tools, and cared for injured group members. Denisovans, known mostly through genetic traces, inhabited parts of Asia. Interactions between these groups were complex, involving competition, coexistence, and interbreeding. Genetic evidence shows that modern humans carry DNA from Neanderthals and Denisovans, indicating that these groups were not entirely separate. Encounters likely occurred in shared landscapes, along migration routes, or in resource-rich regions. These interactions may have contributed to adaptations that helped humans survive cold environments, including immune responses and physiological traits. The cold itself influenced human biology. Ice Age humans tended to have shorter limbs relative to body size, reducing surface area and heat loss. Body mass distribution favoured heat retention. Metabolic demands were high, requiring calorie-rich diets dominated by animal fats and proteins. These physical traits did not arise instantly. They emerged gradually as populations adapted over generations. Diet during the Ice Age was diverse, though heavily dependent on animals. Large herbivores provided meat, fat, marrow, and organs. Smaller animals supplemented this intake. Fish and birds were exploited when available. Plant foods, though seasonal, contributed important nutrients. Early humans were opportunistic rather than specialized, a strategy that allowed them to cope with fluctuating resources. Hunting required planning and coordination. Success depended on understanding animal behavior, seasonal movements, and landscape features. Humans used natural traps such as cliffs, river crossings, and snow-covered ground to their advantage. Tools evolved to support these strategies. Stone points, spears, and later projectile weapons increased hunting efficiency and reduced risk. Tools were not crude improvisations. Ice Age humans produced a wide range of specialized implements. Stone blades were shaped with precision. bone and antler were fashioned into points, needles, and handles. Toolkits varied by region, reflecting local materials and traditions. This technological diversity shows that humans were actively experimenting and refining their methods. Beneath the open sky, communication mattered. Spoken language likely played a central role in coordinating group activities and transmitting knowledge. Gesture, facial expression, and shared routines reinforced understanding. Storytelling, though not preserved directly, almost certainly existed as a way to convey information about places, animals, and past events. Art and symbolic behaviour also emerged during this time. Cave paintings, carved figurines, and decorated tools suggest that Ice Age humans engaged with their world on more than a purely practical level. These expressions were not distractions from survival. They may have strengthened group identity, reinforced shared beliefs, or helped structure memory. Living in a cold, demanding environment likely intensified social interdependence. Illness or injury affected not just individuals but entire groups. Archaeological evidence shows that some injured or disabled individuals survived for years with care from others. This suggests a level of social commitment that went beyond immediate utility. Time beneath Ice Age skies moved differently than it does today. Without clocks or calendars, time was measured through environmental cues, the lengthening of shadows, the return of certain animals, the freezing and thawing of rivers. These patterns structured daily life and long-term planning. Anticipation of future scarcity guided behaviour during times of abundance. Danger was constant but familiar. Predators shared the landscape. Extreme weather posed risks, yet fear did not dominate daily existence. Familiarity bred competence. Early humans learned how to reduce risk through preparation, cooperation, and experience. Survival was not about constant crisis, but about maintaining balance in a challenging environment. As climates shifted, humans adapted. When ice advanced, groups retreated to refuges or altered movement patterns. When ice retreated, new lands opened for exploration. This flexibility allowed humans to spread across continents, reaching regions that would later become deserts, forests, or coastlines. By the later stages of the Ice Age, humans occupied nearly every habitable environment outside the deepest ice sheets. From tundra to steppe, from forests to coastal plains, they demonstrated an ability to adjust without losing continuity. Cultural traditions persisted even as environments changed. The sky itself played a role in shaping human perception. Long winter nights encouraged close social contact around fires. Summer daylight stretching late into the evening allowed extended activity. The movement of stars and seasonal changes may have informed early navigation and timekeeping, grounding human experience in the broader rhythms of the planet. As the Ice Age moved toward its end, warming accelerated. Ice melted. Sea levels rose. Ecosystems reorganized rapidly. Humans faced new challenges, including changing animal populations and shrinking open landscapes. Some groups adapted smoothly. Others struggled. These transitions set the stage for major shifts in human behavior, including increased reliance on smaller animals, fishing, and eventually plant cultivation. Yet even as the world changed, Ice Age experience left a lasting imprint. The skills developed beneath expansive skies did not vanish. They informed how humans responded to new environments. Cooperation, adaptability, and close attention to ecological signals remained central to survival. The lives of early humans during the Ice Age were not defined by misery or heroism, but by persistence. They lived within limits, responded to change, and carried knowledge forward across generations. Beneath cold skies and shifting light, they built the foundations of human culture as we know it. Cold was not an occasional challenge during the Ice Age. It was a constant condition that shaped every decision, every routine, and every moment of daily life. For early humans, survival depended not on rare acts of bravery, but on repeated practical actions carried out day after day. Shelter had to be built and maintained, Fire had to be kept alive. Food had to be found, processed, and shared. Movement had to be timed and deliberate. None of these tasks were optional, and none could be neglected for long without consequences. Shelter was the first line of defense against the cold. The type of shelter people used depended heavily on local conditions, available materials, and season. In regions with caves, these natural formations offered reliable protection. Caves buffered temperature extremes, blocked wind, and provided a stable base from which people could hunt and gather nearby resources. Evidence from archaeological sites shows repeated use of certain caves over thousands of years, suggesting that people returned to places they knew well whenever conditions allowed. Where caves were absent or unsuitable, humans built their own structures. These shelters were not crude piles of debris. They were carefully constructed using materials at hand. Wooden poles formed frames when trees were available. Animal hides, stitched together with sinew, were draped over these frames to block wind and trap heat. In some open plains where wood was scarce, bones and tusks from large animals were used as structural supports. These bone-built shelters were anchored into the ground and covered with hides, creating enclosed spaces that could retain warmth even during severe cold. Placement mattered. Shelters were often positioned to take advantage of natural windbreaks such as hills, rock outcrops, or riverbanks. Entrances were oriented away from prevailing winds. The ground beneath was sometimes lined with vegetation, hides, or even compacted snow to reduce heat loss. Small design choices made significant differences in comfort and safety. Fire transformed these shelters from mere windbreaks into livable spaces. Maintaining fire was a daily responsibility that required planning and vigilance. Fire did not appear easily in a cold, windy environment. It had to be protected from moisture, fed with fuel, and carried from place to place when groups moved. Embers were sometimes transported in containers made of bark, bone, or stone, allowing fires to be restarted without creating sparks from scratch. Fuel availability varied widely. In forested areas, wood was the primary fuel. In open steppe or tundra, dried shrubs, grasses, and animal dung were burned. Bone, rich in fat, could also serve as fuel when other materials were scarce. Each type of fuel burned differently, requiring knowledge of how to manage heat, smoke, and duration. Fire provided more than warmth. It allowed food to be cooked, which increased caloric intake and reduced disease. It softened hides, hardened wooden tools, and enabled the shaping of stone and bone implements. It extended productive hours into the night, creating time for tool-making, repair, and social interaction. Around the fire, knowledge was shared, plans were discussed, and group cohesion was reinforced. Food acquisition structured much of daily activity. Hunting was demanding and unpredictable. Success depended on understanding animal behavior, weather conditions, and terrain. Large hunts required coordination among multiple people, sometimes involving days of preparation. Smaller game could be taken more opportunistically using traps, snares, or simple weapons. Processing food was as important as acquiring it. A large animal provided enormous resources, but only if it could be used efficiently. Meat had to be butchered quickly to prevent spoilage. Fat was rendered or consumed fresh. Marrow was extracted from bones. Organs were eaten promptly. Hides were cleaned and prepared for clothing or shelter. Nothing was wasted because waste meant vulnerability later. Preservation techniques were essential. Meat was dried, smoked, or frozen to extend its usability. In cold environments, freezing acted as a natural storage method, but it required protection from scavengers. Caches were created, sometimes buried or placed in elevated locations. Knowledge of where food was stored had to be shared and remembered, especially when groups moved between seasonal camps. Plant food supplemented animal-based diets. Roots, berries, seeds, and leaves were gathered when available. Though plants rarely provided the bulk of calories in cold environments, they contributed vitamins and minerals that meat alone could not supply. Knowing where and when these plants grew was part of survival knowledge passed down through generations. Water access required careful management. Rivers and lakes could freeze solid in winter, forcing people to break ice or rely on meltwater. Snow could be melted, but this required fuel and time. Dehydration remained a risk even in cold climates. Camps were often located near reliable water sources, and movement patterns reflected the need to maintain access year-round. Movement itself was a constant feature of Ice Age life. People did not wander aimlessly, but followed established routes shaped by experience. Seasonal migrations of animals guided human movement. Camps were revisited year after year, sometimes for generations. These places accumulated traces of human activity, becoming familiar anchors in a shifting world. Travel in cold conditions demanded physical endurance and planning. Snow and ice altered terrain dramatically. Rivers that were obstacles in summer became highways in winter. Conversely, thawing ice could make travel dangerous. People learned to judge ice thickness, recognize weak spots, and adjust routes accordingly. Clothing and footwear were essential for movement. Fur-lined garments protected against heat loss. Boots insulated feet from frozen ground. Gloves and head coverings reduced exposure. Clothing was repaired constantly, because even small tears could become serious hazards. Needlework was not a minor skill, but a critical survival practice. Children were integrated into daily routines early. They learned by observing and participating in tasks appropriate to their abilities. Carrying fuel, gathering small plants, assisting with food preparation, and caring for younger siblings all contributed to group survival. Learning was practical and continuous, embedded in daily life rather than separated into formal instruction. Social organisation supported daily routines. Tasks were divided based on skill, age, and physical capacity rather than rigid roles. Cooperation increased efficiency and reduced risk. Sharing food ensured that individuals who were sick, injured, or unsuccessful in hunting could still survive. This mutual reliance strengthened group bonds. Time perception during daily life was shaped by environmental cues. Without clocks, activities were organised around light, weather, and seasonal changes. The rising and setting of the sun, the length of shadows, and the behaviour of animals all served as markers. Patience was built into routines. Some tasks took days or weeks to complete, and results were not always immediate. Illness and injury were constant concerns. Cold exacerbated infections and slowed healing. Burns, cuts, and broken bones could be fatal without care. Evidence from skeletal remains shows that injured individuals often survived long periods, suggesting that others supported them. Caring for the vulnerable was not a luxury, but part of maintaining group strength. Daily life also included moments of rest. These were not idle periods, but necessary recovery. Energy conservation mattered. Overexertion increased risk. Quiet moments around the fire allowed bodies to recover and minds to process the day's events. These pauses were as important as action. Weather dictated flexibility. Storms could halt travel, force shelter repairs, or disrupt hunts. Adaptability was essential. Plans were adjusted constantly. Rigid schedules did not exist. Instead, people responded to conditions as they arose, using experience to make informed decisions. Despite the demands of cold, daily life was not defined solely by hardship. Familiar routines provided a sense of stability. Returning to known camps, sharing meals, and maintaining social ties created continuity even as environments changed. This continuity helped humans persist through long periods of uncertainty. As the Ice Age progressed and climates shifted, these daily practices evolved. Warmer periods allowed greater reliance on plant foods and more stable camps. Colder phases demanded increased mobility and dependence on hunting. The core principles remained the same: shelter against exposure, fire for transformation, food for energy, and movement guided by knowledge. These routines did not vanish with the end of the Ice Age. They formed the basis for later adaptations as humans transitioned into new environments. The skills developed in cold conditions influenced how people responded to forests, coastlines, and eventually agricultural landscapes. Understanding daily life in the cold reveals that survival was not a series of dramatic moments, but a steady accumulation of practical choices. Each shelter repaired, each fire tended, each meal shared contributed to persistence across generations. Long before survival became something people could take for granted, thought itself was a tool. During the Ice Age, human minds were shaped by constant negotiation with their surroundings. Every decision carried weight, every mistake could ripple outward. And yet, within this demanding environment, humans did more than endure. They imagined, they planned, they experimented, and they expressed ideas that went far beyond immediate necessity. Art, tools, and abstract thinking did not appear despite harsh conditions. They emerged because of them. Toolmaking was not simply about efficiency, it was about foresight. A stone tool was never just a stone. It represented knowledge of materials, anticipation of future needs, and the ability to imagine an object before it existed. Selecting the right stone required understanding fracture patterns, hardness, and availability. Shaping it demanded skill, patience, and muscle memory developed through years of practice. One poorly struck blow could ruin hours of preparation. Ice Age toolkits were remarkably diverse. Stone blades, scrapers, points, burins, and awls were produced with increasing precision over time. These tools were not interchangeable. Each served a specific purpose, whether cutting meat, shaping wood, working hides, or engraving bone. The variety itself reflects complex planning. People anticipated multiple tasks long before they were needed and prepared accordingly. Bone and antler became especially important materials. Unlike stone, they could be shaped into thin, flexible forms without shattering. This allowed the creation of needles with eyes, barbed points, fishing hooks, and decorative objects. Sewing hides into fitted clothing depended entirely on such tools. Without them, humans could not have lived comfortably in extreme cold. Tool-making knowledge was cumulative. Techniques were refined and passed down across generations. This transmission required teaching, observation, and shared standards of quality. A tool that worked poorly endangered not only its maker, but others who relied on it. Over time, groups developed recognizable styles, reflecting cultural identity as much as practicality. Yet tools alone do not explain the leap in human capability during the Ice Age. What stands out equally is the emergence of symbolic behavior. Humans began creating objects that served no direct survival function. Engravings on bone, beads made from shells or teeth. Pigments carried long distances. These items required time, effort, and intention, resources that were never abundant. Cave art provides some of the clearest evidence of this shift. Deep within caves, far from daylight and daily activity, people painted animals with remarkable accuracy and movement. Bison, horses, deer, and mammoths appear layered across walls and ceilings. These were not casual sketches. They were carefully placed, sometimes incorporating the natural contours of rock to give figures depth and motion. The choice of location matters. These spaces were dark, difficult to access, and removed from everyday life. Entering them required firelight, preparation, and likely ritualized behavior. This suggests that the act of creating art was meaningful beyond decoration. It may have been tied to storytelling, teaching, belief systems, or group identity. Art also appeared in portable forms. Small figurines carved from stone, bone, or ivory have been found across Ice Age Europe and Asia. Some depict animals, others depict human forms, often emphasizing certain features. The repetition of these forms across wide regions suggests shared ideas that traveled with people as they moved. Meaning is difficult to reconstruct from these objects alone. What matters more is that humans were thinking symbolically. They were capable of letting one thing stand for another. This ability underpins language, memory, and social cohesion. It allows knowledge to be stored outside the individual, embedded in objects, images, and stories. Storytelling likely played a central role in Ice Age life. Without writing, memory was preserved through repetition and narrative. Stories could encode information about landscapes, animal behaviour, past events, and social norms. They could warn of danger, explain seasonal changes, or reinforce cooperation. Around fires, in long nights, stories became tools as vital as stone blades. Language itself evolved under these conditions. Coordinating hunts, teaching tool-making, and maintaining social bonds required precise communication. Over time, vocabulary expanded to include abstract concepts such as time, intention, and obligation. These linguistic developments supported increasingly complex social structures. Thought at the edge of survival was practical, but not limited to the present moment. Ice Age humans planned for seasons ahead. They anticipated scarcity. They stored food, repaired tools, and maintained social ties with future needs in mind. This future-oriented thinking distinguished humans from many other animals and allowed adaptation to slow but relentless environmental change. Ritual behaviour also emerges in the archaeological record. Burials containing grave goods suggest beliefs about death that extended beyond disposal of bodies. Objects placed with the dead may have symbolised status, memory, or connection to the group. The act of burial itself implies respect and continuity, recognition that individuals mattered beyond their immediate utility. These practices did not replace survival routines. They existed alongside them. Art was created between hunts. Tools were decorated even when plain versions would suffice. Thought expanded into symbolic realms without abandoning practicality. This balance is key to understanding Ice Age humanity. Creativity likely enhanced survival indirectly. Shared symbols strengthened group identity. Groups with strong cohesion cooperated more effectively. Trust reduced conflict. Knowledge circulated more freely. In a harsh environment, social breakdown could be fatal. Symbolic systems helped prevent that breakdown. Tool innovation continued throughout the Ice Age. Techniques such as pressure flaking allowed finer control over stone shaping. Composite tools combined multiple materials such as stone points hafted onto wooden shafts with resin and sinew. These tools required planning across time, gathering different materials from different places and assembling them correctly. Such complexity reflects layered thinking. A person had to imagine the finished tool, understand how its parts interacted, and anticipate how it would perform. This mental modelling ability is a hallmark of modern human cognition and was honed under Ice Age conditions. Artistic expression also required mental flexibility. Depicting animals accurately demanded close observation and memory. Artists captured movement, posture, and behaviour. This observational skill likely overlapped with hunting knowledge. The same attention that allowed an artist to paint a horse mid-stride helped a hunter anticipate how that horse would move across terrain. The distinction between art and survival may be a modern one. For Ice Age humans, these domains were deeply intertwined. Artistic expression could reinforce respect for animals, teach younger members about species behaviour, or encode social values. What appears decorative to us may have been instructional or spiritual to them. Children were immersed in this world from birth. They observed tool-making, listened to stories, and watched art being created. Learning was experiential. Mistakes were corrected gently or decisively depending on risk. Over time, children absorbed not only skills, but ways of thinking about the world. Thought itself was shaped by the environment. Open landscapes encouraged long-distance planning. Seasonal cycles reinforced temporal awareness. Scarcity encouraged sharing norms. Abundance reinforced gratitude and restraint. These patterns influenced moral frameworks long before formal laws existed. Ice Age humans also demonstrated curiosity. They experimented with materials, pigments, and techniques beyond immediate necessity. Some experiments failed, others succeeded and spread. This willingness to explore unknown outcomes is a hallmark of cognitive flexibility and innovation. The presence of art and symbolic objects across vast distances suggests communication between groups. Ideas travelled alongside people. Styles evolved, merged, or diverged. Cultural exchange occurred even in a world without roads or writing. As climates shifted and environments changed, these cognitive tools became increasingly important. Flexibility of thought allowed humans to adjust strategies. When large animals declined, humans diversified diets. When forests expanded, new tools and hunting methods emerged. Thought adapted as environments did. By the later stages of the Ice Age, humans possessed a rich cognitive toolkit. They could imagine futures, preserve memories, cooperate in large groups, and express ideas through objects and images. These abilities did not make survival easy, but they made adaptation possible. The Ice Age did not suppress creativity. It refined it. Constraints sharpened innovation. Necessity encouraged efficiency. Uncertainty rewarded foresight. In this context, art and thought were not luxuries. They were extensions of survival, woven into daily life as tightly as shelter and fire. Not every threat in the Ice Age announced itself with noise or movement. Some arrived quietly, carried on the wind, hidden in the cold, or waiting patiently in patterns people failed to notice until it was too late. Life during this time existed close to a boundary that shifted constantly, a boundary where small misjudgments could tip the balance between survival and loss. Danger was not an occasional interruption. It was a background condition, woven into daily experience, shaping how humans and animals behaved, adapted, and sometimes disappeared. Cold itself was never-present risk, but rarely the most dramatic one. Exposure worked slowly, fingers numbed, muscles stiffened, judgment dulled. A sudden drop in temperature at night, an unexpected storm or damp clothing could become lethal if shelter or fire failed. These dangers did not feel heroic. They were quiet, persistent, and unforgiving. Adaptation meant learning how to prevent problems long before they became emergencies. Weather patterns during the Ice Age were unpredictable on short timescales, even if long-term climate followed a rhythm. Sudden blizzards could erase tracks and landmarks. Strong winds intensified cold far beyond what temperature alone suggested. Thaws followed by rapid freezes created treacherous ice conditions. Early humans learned to read subtle signals in clouds, wind direction, animal behavior, and even the feel of the air. These observations guided decisions about whether to move, stay put, or prepare for worsening conditions. Animals faced similar challenges. Many species developed behavioral strategies to reduce exposure. Herds clustered tightly during storms. Smaller animals retreated beneath snow or into burrows where temperatures were more stable. Predators adjusted hunting schedules, conserving energy during extreme cold and exploiting moments of vulnerability when prey struggled. Starvation was a constant risk, particularly during long winters or periods of ecological disruption. Food shortages rarely arrived suddenly. They crept in as familiar resources became less reliable. A herd that failed to return. A river that froze deeper than expected. A plant that did not reappear in spring. Adaptation required diversification. Groups that relied too heavily on a single food source were more vulnerable than those that spread risk across multiple strategies. Humans responded by expanding diets, developing storage methods, and strengthening social sharing norms. Food sharing was not charity, it was insurance. A successful hunter today might depend on others tomorrow. These reciprocal relationships reduced individual risk but required trust and cooperation. Groups that fractured under stress were less likely to survive prolonged hardship. Predation added another layer of danger. Large carnivores shared Ice Age landscapes with humans, competing for the same prey and sometimes viewing humans themselves as potential targets. Lions, wolves, hyenas and bears posed real threats, particularly to small groups or individuals travelling alone. Defensive strategies included group cohesion, fire use, and careful campsite selection. Fire altered the balance of power between humans and predators. Its light and heat deterred many animals. Fires placed strategically around camps created barriers that reduced nighttime attacks. However, maintaining fire required effort and resources. A fire that went out unexpectedly could leave a group vulnerable at the worst possible moment. Injuries represented a serious risk with long-term consequences. A broken bone, deep cut, or severe infection could be fatal without care. Hunting large animals involved close-range encounters with dangerous prey. Falls on ice or rocky terrain were common hazards. Even minor injuries could become life-threatening in cold environments where healing was slow. Adaptation to injury relied heavily on social support. Archaeological evidence shows individuals surviving injuries that would have been debilitating without assistance. This implies caregiving, food provision, and protection from danger. These practices strengthened group resilience but also increased collective risk. Caring for the injured required resources that could strain a group during lean periods. Disease played a subtler role. Cold conditions slowed the spread of some pathogens but increased vulnerability to others. Respiratory illnesses, infections from wounds, and nutritional deficiencies weakened individuals. Dense living conditions during harsh winters may have facilitated disease transmission within groups. Adaptation involved hygiene practices, movement to reduce exposure, and reliance on medicinal knowledge derived from plants and observation. Environmental change itself was one of the most profound dangers. The Ice Age was not static. Habitats shifted, familiar resources disappeared, routes became impassable, populations of animals rose and fell. Adaptation required recognizing when an environment was no longer viable and having the flexibility to relocate or change strategies. Some species adapted successfully, others did not. Large animals with slow reproductive rates were particularly vulnerable to rapid environmental shifts. When grasslands shrank or forests expanded, grazing specialists struggled. Predators dependent on those herbivores faced cascading effects. Extinction was rarely the result of a single factor. It emerged from a convergence of pressures that exceeded adaptive capacity. Humans too experienced losses. Archaeological records show abandoned sites, population bottlenecks, and regional disappearances. Groups that failed to adapt to changing conditions vanished, leaving little trace beyond scattered tools or fire remnants. Survival was not guaranteed by intelligence alone. It depended on timely decisions and the ability to adjust cultural practices. Adaptation often involved trade-offs. Moving to a new region might reduce exposure to cold, but increase competition with other groups. Shifting diet might alleviate immediate hunger, but introduce nutritional challenges. Settling near water improved access to resources, but increased flood risk. There were no perfect solutions, only better or worse options. Learning from failure was critical. Mistakes were costly, but they also informed future behaviour. Groups that survived did so because knowledge accumulated over generations. Stories of dangerous places, failed hunts, or deadly winters were remembered and shared. Memory became a survival tool, allowing people to avoid repeating errors. Animals exhibited similar learning patterns. Migration routes shifted over time. Predator strategies evolved. Prey behaviour adapted to new threats. These changes did not happen instantly. They emerged through repeated exposure to risk and selective survival. One of the most significant adaptations was flexibility in movement. Groups that remained mobile could respond more effectively to local shortages or environmental shifts. Mobility allowed escape from deteriorating conditions. However, constant movement carried its own risks, including exhaustion, exposure, and unfamiliar territory. Balancing mobility and stability was a continual challenge. The thin line between life and loss was most evident during transitional periods. As climates warmed or cooled rapidly, established patterns broke down, animals moved unpredictably, plants changed distribution, humans faced unfamiliar conditions that tested existing knowledge. These periods saw increased mortality and population turnover. Despite these dangers, Ice Age life was not defined by constant crisis. Many risks were managed through routine. Preventative measures mattered more than emergency responses. Well-maintained clothing prevented exposure. Reliable shelters reduced weather impact. Knowledge of seasonal cycles minimized starvation. These practices transformed danger into manageable risk. Adaptation was cumulative. Each generation inherited strategies refined by those before them. Innovations were tested against reality. Successful ones persisted. Failed ones disappeared. Over time, this process produced cultures finely tuned to specific environments. Yet adaptation had limits. When change exceeded those limits, loss followed. The disappearance of large Ice Age animals illustrates this clearly. Climate shift reduced suitable habitat. Human hunting increased pressure. The combination overwhelmed species that had survived previous cycles. Their extinction reshaped ecosystems and human behavior alike. For humans, surviving these transitions required further adaptation. Diets diversified, toolkits changed, social structures adjusted. The loss of familiar prey forced innovation rather than collapse, but not without hardship. Understanding danger in the Ice Age requires recognizing that survival was rarely dramatic. It was a matter of countless small decisions made correctly more often than not. The margin for error was narrow. Adaptation was not optional. It was constant, ongoing, and deeply embedded in daily life. This thin line between life and loss shaped how humans thought about the world. It fostered caution, respect for uncertainty, and reliance on shared knowledge. It reinforced the importance of community and memory. These traits would prove essential as the Ice Age continued to shift toward its final phase. Change did not arrive with a single warm morning or a dramatic collapse of ice. Instead, it crept in quietly, carried by slightly longer summers, higher sun angles, and subtle shifts in wind and water. For thousands of years, the world had known how to live with ice as a dominant force. Then, almost imperceptibly at first, the balance began to tip. Glaciers that had advanced and retreated many times before started to withdraw more decisively. The Earth entered a phase not of sudden transformation, but of sustained release. This warming phase, often called the Great Thaw, did not mean that cold vanished overnight. Winters remained harsh for many generations. Snow still fell, sometimes heavily. Ice persisted in vast quantities. What changed was the long-term trend. Each summer melted a little more ice than the previous one. Snowlines crept uphill. Seasonal meltwater flowed farther and longer. Over centuries, these small differences accumulated into a global shift that reshaped the planet. The causes of this thaw were rooted in the same slow mechanics that had driven the Ice Age itself. Earth's orbital patterns changed once again, altering how solar energy reached the planet. Summers in the high latitudes grew warmer, allowing winter snow to melt more completely. Ice sheets, once stable or growing, began to thin at their edges. As darker land and water surfaces were exposed, they absorbed more heat than reflective ice, accelerating warming through feedback loops that reinforced the trend. As ice retreated, it released enormous volumes of water. Meltwater poured into rivers, lakes, and oceans, raising sea levels across the globe. This rise did not happen smoothly. It occurred in pulses, sometimes rapidly when large ice dams failed or ice sheets destabilized. Coastlines shifted inland. Low-lying plains disappeared beneath the sea. Areas that had supported human and animal life for thousands of years were slowly, then more quickly, submerged. For people living along these coasts and river valleys, the changes were impossible to ignore. Camps had to be relocated repeatedly as water encroached. Familiar landmarks vanished. Travel routes altered. What had once been dry ground became marsh, then shallow water, then open sea. These changes unfolded over generations, allowing adaptation, but they still carried loss. Places remembered by elders became stories rather than destinations. Inland, retreating ice transformed landscapes in different ways. As glaciers melted, they left behind vast amounts of sediment. Meltwater rivers carved new channels through this material, sometimes changing course dramatically as conditions evolved. Floodplains expanded, wetlands formed, new lakes appeared in depressions left by ice. These water bodies created fresh habitats that quickly filled with life. Vegetation responded rapidly to warming conditions. Plants that had persisted in refuges during the cold began to expand their ranges. Tundra retreated northward or uphill. Grassland shifted. Forests advanced into areas that had been open plains for millennia. Trees such as birch, pine, and spruce moved gradually, spreading seed by seed. Over centuries, entire regions changed character. These shifts altered animal life profoundly. Species adapted to cold, open environments found their habitats shrinking. Grazing animals dependent on grasslands faced competition from expanding forests. Some migrated to higher latitudes. Others retreated into remaining open areas. Predators followed or adapted to new prey. Ecosystems reorganized in complex, often unpredictable ways. For humans, the Great Thaw was both opportunity and challenge. Warmer temperatures reduced the risk of exposure. Longer growing seasons increased plant availability. New resources emerged, including fish in expanding rivers and lakes, waterfowl in wetlands, and forest animals moving into newly wooded areas. At the same time, familiar hunting grounds changed or disappeared. Large Ice Age animals declined rapidly, reducing access to high-calorie prey that had sustained people for generations. Human groups responded with flexibility developed over thousands of years. Diets diversified further. Fishing became increasingly important. Small game hunting intensified. Plant foods played a larger role in daily sustenance. Technologies adapted to new conditions. Tools suited for open plains were supplemented or replaced by those effective in forests and wetlands. Movement patterns changed as well. Seasonal migrations adjusted to track new resource distributions. Some groups became more localized, returning repeatedly to productive areas rather than traveling long distances. Others continued to move widely, exploiting transitional environments where different ecosystems met. The rising seas that ended land bridges had lasting consequences. Connections between continents were severed. Populations that had once been part of continuous networks became isolated. Cultural traditions diverged. Genetic exchange slowed. Boats and watercraft became more important for maintaining contact across water, marking a shift in how humans related to their environment. As ice sheets melted, the Earth's crust responded. Land previously compressed by ice began to rise slowly, a process that continues in some regions today. This rebound altered coastlines further, sometimes lifting former shorelines above current sea level. The landscape became a palimpsest of past conditions, with traces of former beaches, riverbeds, and ice margins visible to those who learned how to read them. Climate variability did not vanish with warming. Instead, it intensified in some respects. Rapid melt events disrupted ocean circulation. Freshwater influx altered currents that distributed heat globally. Weather patterns shifted, sometimes unpredictably. Periods of warming were interrupted by brief returns to colder conditions. These fluctuations tested adaptability once more. The disappearance of Ice Age giants accelerated during this time. Mammoths, mastodons, giant deer, and other large animals declined across most of their ranges. The reasons were multiple and interconnected. Habitat loss reduced suitable environments. Human hunting pressure increased as populations grew and spread. Climate change altered food availability. Together, these factors pushed many species beyond recovery. The loss of these animals reshaped human societies. Large game hunting became less central. Social organisation adapted to different resource strategies. Storage methods changed. Settlement patterns adjusted. The end of the Ice Age was not a single turning point, but a series of adjustments unfolding over thousands of years. Culturally, this period saw increased regional diversity. As groups became more settled or adapted to specific environments, traditions diverged. Tool styles, dwelling forms, and subsistence strategies reflected local conditions more strongly than before. Knowledge became increasingly place-based. The thaw also reshaped the emotional landscape of human life. While direct evidence is limited, it is difficult to imagine that people did not notice the changing world around them. Retreating ice, rising waters, and shifting animal populations would have altered how people understood continuity and change. Stories passed down through generations likely recorded memories of colder times, reinforcing identity and shared history. Plants played a critical role in stabilizing newly exposed land. As ice retreated, pioneer species colonized bare ground, reducing erosion and building soil. Over time, these plants prepared the way for more complex ecosystems. This process slowed landscape instability and created conditions suitable for long-term human occupation. Wetlands formed by meltwater became particularly important. Rich in biodiversity, they provided reliable food sources and materials. Fish, birds, and plant resources could be harvested predictably. Many early post-Ice Age settlements clustered around these environments, reflecting their importance in a changing world. The Great Thaw also altered the timing of seasons. Spring arrived earlier, autumn extended longer. These changes affected animal behaviour, plant growth, and human planning. Calendrical awareness became increasingly valuable. Observing seasonal patterns allowed people to anticipate resources and adjust activities accordingly. While warming eased some challenges, it introduced others. Increased rainfall in some regions led to flooding. Thawing permafrost destabilized ground. Forest expansion reduced visibility and altered hunting dynamics. Adaptation remained essential. The end of the Ice Age did not represent a clean break from the past. Many Ice Age practices persisted long into warmer periods. Clothing techniques, social cooperation, and knowledge transmission remained rooted in Cold World experience. The thaw built upon these foundations rather than erasing them. From a planetary perspective, the release of ice marked a profound reorganization. Oceans rose, currents shifted, atmospheric composition changed, ecosystems reassembled, life adjusted, as it always had, to new constraints and opportunities. For humans, the thaw set the stage for developments that would later transform the world even more dramatically. Stable climates in some regions allowed experimentation with plant cultivation. Sedentary lifestyles became more viable. Population growth accelerated. These changes lay ahead, but they were made possible by the gradual release of ice. Yet even as the planet warmed, ice did not disappear entirely. Polar regions retained massive ice sheets. Mountain glaciers persisted. These remnants continued to influence climate and water systems. The Earth never returned to a pre-Ice Age state. It moved into something new. The Great Thaw reminds us that planetary change is rarely abrupt. It unfolds through accumulation, feedback, and adaptation. For those living through it, change was experienced not as a single event, but as a series of adjustments layered across generations. As ice released its grip, it did not simply retreat. It handed the planet over to new dynamics. Land once shaped by grinding ice became shaped by roots, rivers, and human hands. The Ice Age world faded gradually, leaving behind a transformed Earth that carried both loss and possibility. Long after the cold loosened its hold and the great ice sheets began to retreat, the consequences of the Ice Age did not simply fade away. Instead, they unfolded slowly, unevenly, and with lasting impact. Some forms of life adapted and carried forward into the warmer world that followed. Others declined, fragmented, and eventually vanished. Extinction and survival were not opposing outcomes decided in a single moment. They were parallel processes unfolding side by side, reshaping the planet into something permanently different from what had existed before. The disappearance of Ice Age animals is often described as a sudden loss, but in reality, it was a prolonged unravelling. Many large species had survived multiple cold cycles before. Mammoths, mastodons, giant ground sloths, saber-toothed cats, and enormous deer had endured advancing ice, retreating ice, shifting vegetation, and changing sea levels. What made the final phase different was not a single factor, but the convergence of several pressures acting at once. Climate change played a central role. As the world warmed, habitats that supported large, cold-adapted animals shrank or transformed. Open grasslands gave way to forests in many regions. Tundra retreated northward. Seasonal patterns became less predictable during periods of rapid warming. For animals specialised for grazing on cold steppe vegetation, these changes reduced food availability and fragmented populations. At the same time, human presence expanded. As Ice Age humans adapted successfully to a wider range of environments, their numbers grew. They moved into areas newly freed from ice and followed animal populations into shrinking habitats. Hunting pressure increased, not necessarily because humans hunted more aggressively, but because fewer animals remained to absorb that pressure. Even low levels of sustained hunting can destabilise populations of large animals that reproduce slowly. Large animals were particularly vulnerable due to their life histories. Long gestation periods, extended parental care, and low reproductive rates meant that population recovery was slow. When deaths outpaced births for extended periods, decline became inevitable. Environmental stress reduced resilience further, making even small disruptions potentially catastrophic. Extinction was not uniform across the globe. Some regions lost their large animals earlier than others. In parts of Australia, megafauna disappeared tens of thousands of years before the end of the last ice age, likely influenced by early human arrival combined with climatic shifts. In the Americas, many large species vanished near the end of the Ice Age, coinciding with rapid warming and expanding human populations. In parts of Eurasia and Africa, some large animals survived, reflecting differences in climate stability, human coexistence, and ecological structure. Not all Ice Age animals disappeared. Many survived by adapting. Wolves, foxes, bears, deer, bison, and reindeer persisted by adjusting ranges, diets, and behaviours. Smaller animals with faster reproductive cycles adapted more readily to changing conditions. Birds altered migration routes. Fish followed new waterways. Insects shifted life cycles to match new seasonal patterns. Plants also experienced loss and survival. Some cold-adapted species retreated into shrinking refuges, persisting only in high latitudes or mountainous regions. Others disappeared entirely when suitable conditions vanished. Meanwhile, forests expanded, reshaping ecosystems. New plant communities formed, supporting different combinations of animals and altering food webs permanently. For humans, the disappearance of large Ice Age animals forced significant changes. Hunting strategies had to adapt. Reliance on a few massive prey species gave way to broader subsistence strategies. Fishing, bird hunting, small game trapping, and plant gathering became increasingly important. Tools diversified. Storage methods improved. Settlement patterns shifted toward environments with more predictable resources. This transition was not easy. Archaeological evidence suggests periods of stress, population decline, and cultural disruption. Knowledge that had been effective for generations no longer applied in the same way. Humans had to experiment, innovate, and sometimes fail before new strategies stabilized. Survival depended on flexibility rather than tradition alone. Extinction reshaped ecosystems in ways that extended beyond the loss of individual species. Large herbivores had played critical roles in maintaining open landscapes through grazing and movement. Their disappearance allowed forests to spread into former grasslands. This shift altered fire regimes, soil composition, and nutrient cycles. Predators that depended on large prey declined or adapted to smaller animals. These ecological cascades transformed the planet. Landscapes that had existed for tens of thousands of years under Ice Age conditions disappeared. New ecosystems emerged, not as improved versions of the old, but as fundamentally different systems. The world did not simply warm, it reorganized. Humans became increasingly influential in shaping this new world. Fire use, hunting, and later land modification affected vegetation patterns. As human populations grew and spread, their cumulative impact on ecosystems increased. While early humans did not control nature in a modern sense, their actions contributed to long-term change. Culturally, the end of the Ice Age marked a shift toward greater regional diversity. As environments stabilized in some areas, groups developed distinct ways of life. Tool styles, food preferences, and social structures reflected local conditions. Cultural traditions became more deeply tied to place. Memory of the Ice Age likely persisted long after its end. Stories of cold times, giant animals, and changing lands may have been passed down through generations. While these memories are not preserved directly, echoes of them appear in myths, oral traditions, and symbolic art across cultures. The concept of loss itself may have taken on new meaning. People who lived through the disappearance of familiar animals and landscapes experienced change not as an abstract process, but as something deeply personal. Places once rich with life became quiet. Hunting grounds became forests. Shorelines vanished beneath rising seas. These changes shaped how people understood impermanence and continuity. Survival, in this context, was not just biological, it was cultural. Knowledge systems that adapted persisted. Those that remained rigid faded. Social structures that supported cooperation endured. Those that fractured under pressure dissolved. Human survival was inseparable from social resilience. From a planetary perspective, the Ice Age left an enduring legacy. Modern coastlines, river systems, soils, and ecosystems all bear its imprint. The distribution of species today reflects pathways opened and closed by ice and sea. Even climate patterns retain echoes of glacial history. The world that emerged after the Ice Age was not simply warmer, it was more complex, more interconnected, and more heavily influenced by a single species capable of reshaping environments through behavior and technology. Humans did not become dominant overnight, but their role grew steadily as other large species disappeared. Extinction remains a sensitive subject because it reflects limits. The Ice Age demonstrates that even well-adapted species can vanish when change outpaces adaptation. It also shows that survival often depends less on strength than on flexibility, cooperation, and timing. Looking back, it is tempting to view the Ice Age as a closed chapter, but its effects are ongoing. Modern ecosystems are products of that ancient transition. Human societies still grapple with the consequences of inherited landscapes shaped by ice, extinction, and survival. The world was forever changed not by a single ending, but by many gradual losses and adjustments layered over time. What survived did so because it could bend without breaking. What vanished reminds us that persistence has limits. Even now, with ice sheets confined to the poles and high mountains, the Ice Age has not fully receded into silence. It remains present in the shape of the land, in the movement of water, in the distribution of life, and in the habits of our own species. Its influence is not loud or dramatic. It does not announce itself. Instead, it lingers quietly, woven into the background of the modern world, offering lessons that can still be heard if we slow down enough to listen. The Ice Age whispers first through the ground beneath us. Much of the soil that supports modern agriculture was shaped by glaciers, Fine sediments ground from rock by ice were carried by wind and water, then laid down across continents. These deposits became fertile soils that now sustain billions of people. Rolling hills, wide valleys, and lake-dotted landscapes owe their existence to ice that vanished thousands of years ago. Even cities sit atop this inheritance, often without awareness of how deeply their foundations are tied to ancient cold. Water still follows paths carved by ice. Rivers trace valleys widened by glaciers. Lakes occupy basins scooped from bedrock or blocked by glacial debris. Coastlines reflect rising seas that drowned Ice Age plains. When we look at a map, we are seeing a frozen moment in a much longer story of advance and retreat. The Ice Age reorganized the planet's plumbing, and we continue to live with the results. Life, too, carries the Ice Age forward. The distribution of plants and animals across the world reflects ancient migrations made possible by lowered seas and connected continents. Species that coexist today may share a history of survival in cold refuges or joint expansion into newly opened land. Genetic patterns still reveal where populations were once isolated by ice or reunited by its retreat. Human beings are no exception. Our bodies, behaviours and social structures were shaped during long periods of climatic instability. Cooperation, planning and adaptability were not optional traits. They were necessities. The ability to read environmental signals, share resources and adjust behaviour over generations allowed humans to persist through repeated challenges. These traits did not disappear when the ice melted. They became embedded in culture and cognition. The Ice Age also whispers through memory, even when that memory is indirect. Myths of great floods, lost lands, and vanished creatures appear in cultures around the world. While these stories cannot be traced neatly to specific events, they echo experiences common to Ice Age transitions. Rising seas, changing landscapes, and the disappearance of familiar animals left deep impressions on early human communities. Stories preserve these impressions long after the details faded. There is a tendency to view the Ice Age as a time of hardship overcome, a stage humanity passed through on the way to something better. This framing misses something essential. The Ice Age was not merely an obstacle, it was a formative period. Many aspects of what we consider uniquely human were refined under its conditions. Language complexity, symbolic thought, social cooperation, and technological innovation all deepened during this time. Listening to what the Ice Age still whispers means recognizing that stability is not the default state of the planet. Change is. For most of Earth's history, climates have shifted, sea levels have risen and fallen, and ecosystems have reorganized. The relatively stable conditions of the recent past are unusual when viewed across deep time. The Ice Age reminds us that long-term balance often includes fluctuation rather than constancy. This perspective does not diminish the significance of modern change. Instead, it adds context. During the Ice Age, change unfolded slowly enough to allow adaptation. Today, many changes are occurring far more rapidly. The contrast highlights both the resilience of life and its limits. The Ice Age shows that adaptation is possible, but also that it has boundaries. Extinction during the Ice Age offers another quiet warning. Species that had survived multiple climate cycles still vanished when pressures converged too quickly. Habitat loss, climate shifts, and human activity combined to overwhelm even well-adapted animals. This pattern is not confined to the past. It is repeating in different forms today. The Ice Age reminds us that loss is often cumulative, not sudden. At the same time, survival during the Ice Age offers guidance. Life persisted through diversity, flexibility, and cooperation. Ecosystems that supported multiple strategies were more resilient. Human groups that shared resources and knowledge endured longer than those that fractured. These principles remain relevant in any era of change. The Ice Age also reshaped humanity's relationship with time. Living within long climatic cycles encouraged patience and foresight. Decisions were made with future seasons and generations in mind. While modern life often prioritises immediacy, the Ice Age perspective emphasises continuity. Actions taken today echo forward, just as past actions continue to shape the present. There is also a quieter lesson about humility. During the Ice Age, humans were not masters of their environment. They were participants within it. They adapted to forces far larger than themselves. Even their innovations were constrained by what the land and climate allowed. This sense of being part of a larger system, rather than above it, remains an important reminder. The Ice Age whispers through patterns of movement as well. Modern migration routes, trade paths, and cultural connections often trace ancient corridors opened by ice retreat or sea level change. These pathways shaped human history long before written records. Understanding them deepens our sense of connection to place. In daily life, remnants of Ice Age adaptation persist in subtle ways. Clothing design, shelter concepts, food preservation techniques, and social rituals around sharing and cooperation have roots in Cold World survival. While contexts have changed, the underlying logic remains. Listening to the Ice Age also means acknowledging uncertainty. Ice Age humans lived without guarantees. They responded to change with observation rather than prediction, adjustment rather than control. This mindset fostered resilience. It allowed people to live with uncertainty without paralysis. In a world facing rapid environmental shifts, this approach offers a valuable counterpoint to fear-driven responses. The Ice Age does not whisper in commands or prescriptions. It offers perspective. It reminds us that the planet has changed dramatically before and will change again. It shows that life can persist through transformation, but not without cost. It teaches that survival favours those who adapt early rather than resist until options narrow. Even the quietness of the Ice Age story matters. Change did not always arrive as catastrophe. Often, it arrived as a series of small shifts that accumulated over time. Paying attention to gradual change mattered as much as responding to sudden events. This attentiveness is a skill worth remembering. As night settles and the world grows quieter, the Ice Age feels distant, yet its traces are close at hand. In the curve of a valley, in the soil of a field, in the instincts that guide cooperation and caution, its presence remains. It does not demand attention, it simply waits, woven into the fabric of the present. What it whispers is not a warning alone, nor a comfort alone. It is a reminder of continuity. The Earth we inhabit is the result of countless past changes. We are part of that ongoing process, shaped by what came before and influencing what will follow. Listening does not require fear or nostalgia. It requires awareness. Awareness that landscapes have memories, that life adapts within limits, that survival and loss are intertwined, and that the quiet lessons of deep time are still available to those willing to pause and notice them. As this long journey through the Ice Age settles into stillness, there is no sharp ending, no final conclusion. The story does not close. It continues, carried forward in the land, in living systems, and in human choices yet to be made. The Ice Age has finished its active work, but its quiet presence remains, whispering into the present, inviting reflection rather than resolution, and reminding us that the past is never as distant as it seems.